Welcome everyone to day 2 of the Cobalt Conference, from wherever you are joining us from. I'm Peter Viss. I'm a senior advisor at Rudd Peterson Public Affairs in Brussels. Previously, I worked for 30 years in the European Commission on climate change, energy and transport policies, but particularly climate, where for 5 years I served as the Chief of Staff to the Commissioner for Climate Action. I'm very happy to both welcome you back after yesterday and to introduce the day ahead. You know, of course, that today the focus is on batteries. And batteries have an integral role in addressing climate change. There's lots going on climate at the moment. The US President Biden's climate summit took place on the 22nd and 23rd of April. The EU's climate law has recently been agreed, and there is a package of forthcoming legislation going to be proposed by the European Commission in June. In November this year, there is the next conference of parties of the United Nations Framework Convention on Climate Change in Glasgow. So there's lots of relevant context to what we're going to talk about today. Global action is necessary to address climate change, and often it will entail regulations that directly or indirectly impact on batteries and the materials with which they are made. Analysis from the European Commission shows that large investments are needed to meet the European Green Deal's ambitions. Around 350 billion euros additional annual investment is needed as compared to the period up to 2020. So today's conference will dwell on the role of cobalt in batteries. 55% of cobalt is used in batteries, making it an essential discussion point, whether you're a battery manufacturer or not. Like the global challenge that climate change presents, cobalt too has a global role. I want to just dwell for a short on an example that I've seen during my career, where I've seen new technologies scale up and whole new supply chains be created. Back in 2007 to 2010, I was working for the Energy Commissioner at the European Commission, and we were setting renewable energy targets for the EU member states. These were targets that the member states had to meet by 2020. They were big stretch targets, to put it mildly. Most renewables back in 2007 was hydro electricity. Renewable energy technology costs that offered scale, such as offshore wind, were expensive and needed fixed rate subsidies that only richer member states could afford. In short, policies and subsidies drove the market forward for wind energy and offshore wind in particular, from both a demand and a supply perspective. Those renewable targets, they pumped up demand, and it turned out that the big integrated electricity generators were blindsided by the potential. They didn't see a threat coming to their business model. Within a relatively short time, regulation required renewable energy to be taken first by the electricity grid operators when it was available. And when the sun shone and the wind blew, the fossil generators were being switched off in order to let the renewable energy come on. And this progressively ate away at the market share of fossil fuel incumbents whose profits became less predictable. And gradually the business model of big fossil electricity generation was undermined as the costs of competition fell. Renewable energy supply chains were developed, their scale increased with the ensuing falling of costs. The advent of carbon pricing in Europe gave renewables a free pass but burden the CO2 emitters. So sometimes it's a combination of different regulations that really accelerate change. And basically, in the space of 15 years, the power generation landscape has been transformed. And this transformation is happening now across the world. Oh, and by the way, we did meet those renewable energy targets in 2020 in Europe. And every sign is that renewable energy will continue its growth trajectory, with renewable energy increasingly being produced and stored locally. Looking ahead, the technology costs and economies of scale look good for batteries and large-scale storage. The possibility of off-grid autonomy is fast becoming a reality in many parts of the world. And I can see parallels between the offshore wind story and the position of batteries today. We want more of them, and we want to produce them ourselves. So we need to work together to align investment and the building of an ecosystem of producers and service providers, just as has happened for offshore wind, for which we needed dedicated vessels for building offshore wind farms. Given the increasing size of the turbine blades and towers, there had to be facilities built on the coastal areas, and workers had to be trained with the necessary skills. I was born near a coastal estuary city in the east of England that has benefited enormously from new factories and a host of service providers with engineering know-how and the skilled jobs for people trained up to work in the offshore wind industry. And the United Kingdom's Prime Minister has even said he wants the UK to become the Saudi Arabia of wind energy. Now, transport's another area I worked on. It's a little bit the problem child of climate action, because transport emissions are today 20% higher than they were in 1990. Here again, we're seeing regulation once again pushing technologies into the market that are cleaner, more electrified, and whose costs are coming down. The writing is on the wall that this transition too will be a game changer for some, and it's happening all over the world. Road transport is increasingly about new powertrain technologies, cost reductions, and the deployment of new infrastructure, the creation of new ecosystems of suppliers, all of which, of course, has geopolitical consequences as well, as technologies pivot away from oil and towards batteries, for example. So batteries have a critical role to play, and Europe wants to create and build whole new supply chains, as has happened in the case of wind energy. And today we're going to hear and discuss how the EU's plans to ensure breakthroughs in battery technologies are lining up. We have an impressive program, an impressive list of speakers to talk about what is being done both here in Europe and elsewhere in the world. And it's my pleasure, therefore, to introduce the first speaker of the day, who works at the European Commission, where I used to work. It's the director in the Directorate General Change for Internal Market and Industry, Mr. Joachim Nunes de Almeida. So, Joachim, if I may give you the floor, the microphone is yours. Thank you.
Thank you very much. Thank you very much, Peter. So, very briefly, very happy to be here today with you. The EU is committed to the transition to climate neutrality, fully committed. The Green Deal is our vehicle for taking the lead in becoming a climate neutral continent based on sustainability, green energy, and circular economy. And this ambitious goal will require significant changes in our economies and supply chains. And this includes raw material supply chains, which is going to be the focus of my intervention today. We've just published an update to our industrial strategy on the 5th of May to take into account the lessons learned from the crisis, the need to analyze and address strategic dependencies. We're not the only people in the world thinking about it, but we are thinking about it. The need to strengthen the resilience of the single market, and the need to accelerate the twin transition, digital and green, and support its business case. So DG Grow sees itself very much as developing the business case for the twin transition. We need to ensure a secure and sustainable supply of raw materials to meet the needs of the clean and digital technologies, including batteries and e-mobility. Not immobility, e-mobility. This will need to be addressed through a combination of rethinking the way we consume resources, becoming more circular, and ensuring that new mining and refining activity is done as sustainably as possible. The Action Plan on Critical Raw Materials, put forward in September last, sets out concrete steps to achieve this. It presents 10 actions to develop resilient EU value chains that should be more circular. They should do more sustainable sourcing and processing in the EU, and diversify supply with sustainable and responsible sourcing from third countries. The EU and the member states already have a good legislative framework in place to ensure that mining takes place under environmentally and socially sound conditions. However, more sustainable sourcing and processing from within our borders is hampered by, unfortunately, low public acceptance. We need to listen to and address the concerns that lie behind this paradox. Often public opinion is very much with us in fighting climate change, but we need to see what we can do to get them also to understand that we need to be given the means to face climate change. One example worth mentioning for this is a forthcoming dedicated roundtable on sustainable raw materials for the green and digital transition. The result of the work by the Raw Materials Supply Group on EU principles for sustainable raw materials will be presented at the roundtable, a voluntary initiative which addresses the social, economic governance, and environmental aspects of sustainable extraction and processing in the EU in alignment with the SDGs. The ambition of our industrial policy, now turning to raw materials and batteries value chain, the ambition of our industrial policy is to have an industry that creates value-added jobs in all regions across Europe, driven by innovation, quality, respect for the environment, rather than by lowering labor costs. We must also always remember that raw materials provide an essential foundation to all our industrial ecosystems, and this is especially true of batteries value chain. The European battery ecosystem is an excellent example of a sector that is driven by innovation, quality, and the respect for the environment. It is also economically strategic, as it is at the heart of our ambitions for zero emissions mobility and energy storage, and on which our long-term goals for climate neutrality depend. This is why we attach such a high priority to establishing a competitive, sustainable, and complete battery ecosystem in Europe. These objectives lie at the heart of the European Battery Alliance, launched in 2017, at a time that there was no significant battery value chain in Europe at all. Europe only had 3% of the global battery market. We're talking about 4 years ago. And thanks to strong and sustained cooperation between the Commission, member states, and industry, substantial progress has been made. We have become the world's battery hotspot, attracting 60 billion euro investments in 2019, with several more on a similar scale announced in 2020. We're even on track to satisfy nearly all EU battery cell demand with sustainable battery cells produced in the EU by 2025. This is particularly impressive as demand is growing fast. In 2020, 1 million electric vehicles were sold in the EU, which represents over 10% of new cars registrations, as compared with 3% the year before. 10% compared to 3% the year before. An important element in generating this momentum has been the two important projects of common European interest, what we call IPCEIs, on batteries that have been approved. They involve 59 enterprises from 12 member states and represent together 20 billion euro of private and public investment. However, this enormous success has highlighted bottlenecks to further growth, including access to raw materials. The Commission regards raw material projects, refining included, as strategic. As you will be aware, our industry depends on a number of raw materials that are mostly imported from third countries. We import 100% of refined lithium for electric cars, platinum to produce clean hydrogen, and silicon metal for solar panels, 100%. 98% of the rare earth elements we need come from a single supplier, China. This is not sustainable. Europe needs to diversify its supply chains while investing in circular technologies that reuse resources instead of constantly extracting them. The Commission has taken several steps to ensure a secure and sustainable access to raw materials for our industry in general. The 2020 list of critical raw materials for the EU includes some of them especially relevant for batteries: cobalt, natural graphite, and lithium. We need to see how accelerating permitting processes and how can we get an increased social acceptance of those projects and provide the financial support. So permitting processes, increased social acceptance, and providing financial support. In addition, increased access to raw materials from third countries via diplomacy and trade agreements and recycling will play an important role. We have proposed a legal framework setting clear rules to ensure that batteries perform and that they're produced sustainably. The Commission proposal addresses the entire battery life cycle, from transparent supply chains for battery raw materials based on OECD due diligence guidelines, through provisions for recycling and material recovery, to minimum recycled content for future batteries. This should mainstream circularity and reinforce secondary raw materials markets. On the 12th of March, there was a high-level meeting of the European Battery Alliance, chaired by Vice President Šefčovič, together with Commissioners Breton, Schmidt, and Ferreira, and ministers representing member states active in supporting battery projects. While this meeting welcomed the enormous progress that had been made in establishing a genuine European battery ecosystem, they were unanimous in stressing the importance of tackling the bottlenecks facing industry. At this meeting, it was agreed that the Commission and Member States will work towards addressing the key aspects of environmental and social sustainability and public acceptance linked with raw material projects. To support these efforts, the Commission will organize this year a roundtable on the environmentally and socially sustainable raw materials mining and publish a common and non-regulatory set of EU principles for sustainable raw materials. In conclusion, ladies and gentlemen, I'm coming to an end. The sustainably sourced and processed raw materials are at the core of the green and digital transition, and their importance will only grow going forward. A fully operational and vertically integrated battery ecosystem is essential not only for achieving the green transition, but also for preserving the global competitiveness and resilience of the European industry and developing our open strategic autonomy. Raw materials and batteries ecosystem and the batteries ecosystem contribute significantly to the green economic growth and the EU social agenda, with innovative and sustainable recovery projects creating thousands of jobs, including in the regions most affected by the climate and digital transitions. Thank you very much for your attention, and thank you very much for having invited me to this opening speech today.
Thank you very much, Mr. Nunes de Almeida, for your words. I think you're absolutely right that we need to develop the business case for the green transition. And I think many of the people listening will really welcome those words. And I think from our perspective, the Cobalt Institute is at the heart of delivering those ambitions, and we're always available to support you on them. As you've heard, the batteries industry is critical for the future of the green economy and by extension, the global economy. And that makes cobalt critically important too. While that brings opportunities, it also brings unprecedented scrutiny, not only for cobalt, but also the entire cobalt value chain. My name is Mike Blakeney. I'm Senior Manager for Government and Public Affairs at the Cobalt Institute. And if there's one thing that's increasingly clear, is that policymakers around the world are increasingly focusing on resilient and sustainable sourcing of cobalt. They're also focusing on the future regulation of these substances and of the batteries they go into. And the EU, as it is so often, is the first mover, but others are likely to follow. With that in mind, I'm really pleased to introduce the next panel event, where we'll be talking about the EU's battery regulation in a global context. But before we do that, we wanted to show a video that has been provided for this conference by Senator Lisa Murkowski, the United States Senator for Alaska, which is a position she's held since 2002, and she is a leading figure on critical minerals in the US. She was the author of the 2020 Energy Act, which included the American Minerals Security Act. And she also continues to champion US critical mineral resilience in the Senate through her critical minerals permitting bill, which has similarities to what Mr. Nunes de Almeida was just talking about in the EU context, and also the Strategic Energy and Minerals Initiative Act. So with that, we'll play a short video from Senator Murkowski.
Good morning, everyone. Thank you for having me here today. It's great to talk to a group that's on the front lines of what I believe to be one of the nation's most pressing economic and national security vulnerabilities, and that is critical minerals. For over a decade now, I've been championing solutions here in Congress that would help secure our domestic production and supply chains of these resources, which are absolutely critical to modern life and the development of future technology. This is everything from advanced nuclear, renewables, batteries, to advanced missile systems. Last year, really at the 11th hour before the new Congress, I was really just so pleased to be able to see my Energy Act enacted as part of the Consolidated Appropriations Bill that was signed into law on December 27th. Part of this bill was my American Minerals Security Act, which created directives across the federal government for agencies to implement strategies, policies, and missions that are related to critical minerals. And this includes agencies and departments ranging from the Department of Energy to the Department of Labor, as well as our land management agencies. I think that this legislation was an important first step to get the ball rolling on a whole of government approach to tackling the critical minerals challenge. Most recently, I've introduced two pieces of legislation, a critical minerals permitting bill and my Strategic Energy and Minerals Initiative Act, or the SEMI Act. The former implements mandates for federal land management agencies to improve the efficiency of their permitting processes for critical minerals projects on our federal lands. As I'm sure all of you know from experience, that mining projects can take well over a decade to begin operation with permitting and review. Now, the SEMI Act leverages the United States' influence in international finance to make our resources more competitive in global trade, and it also seeks to counter growing Chinese influence and dominance over resource and mineral projects that are overseas. We know that we've got so many of these resources and so many promising projects that would be secure supplies of these minerals, including cobalt, and these supplies are in front of us for years to come. I'm pleased that critical minerals have become more of a focus in Congress and the executive branch over the last several years. The previous administration took some solid steps to advance the nation's mineral security. The current administration has also shown some promising interest in the issue, but I hope to see more definitive action from the president and his advisors soon. I think we recognize that we can't let this get in front of us. We can't wait any longer. Let's get moving today. Thank you for all that you do.
Hello, everybody, and welcome back. And thank you also to Senator Murkowski for the video that you saw just before the break. I'd like to welcome you all to the first panel of the day on the batteries regulation. I think we've got some really interesting speakers, and thank you to them all for attending. But before we do that, I thought it might be useful just to introduce Fast Markets, who will give a broad overview of the issues that we're talking about today. So with that, Dalila, perhaps I can hand over to you.
Thank you so much, and hello everyone, and thank you for joining us for this presentation. My name is Dalila Werghi, and I work for Fast Markets as a senior price reporter covering the cobalt sector alongside Michael Greenfield. Fast Markets is a leading PRA in the metals industry, and we also have a research department looking at price and fundamentals forecasting. Michael and I are part of a global team assessing a number of cobalt prices that are used as physical and financial benchmarks in the market. We're going to distill the main proposals of the EU battery regulation and what it means for this critical battery raw material, cobalt. I will discuss the implication of the EU climate targets for cobalt, while Michael will give you an overview of the EU battery regulation and its implication. If you find time after the presentation, please read our disclaimer policy. So the European Green Deal that you all know set very ambitious targets up to 2050 with a number of intermediate milestones along the way. I think it's important to draw attention to the fact that by 2030, at least 30 million zero-emission electric vehicles will be on the road in Europe, and therefore battery raw materials that enable these transitions are under the spotlight. The COVID pandemic that hit us last year definitely slowed the global economy, but I think for the European energy transition and the pace that is gaining, it's important to highlight that the recovery fund that was approved last summer of over 750 billion euro points to a greener recovery of the continent. And I also would like to mention some key European jurisdictions and growth that EU EV sales has seen in these countries such as Denmark, Germany. Norway set up a deadline for the phase out of ICE cars. So these are all important news that show how Europe is really focused on enabling this transition. As you can see on this chart from our research department headed by Will Adams, I just want to briefly bring your attention to the purple box that shows the EV sales in Europe between 2019 and 2020. And they've been growing, EV sales in Europe have been growing at a compound annual growth rate between 2018 and 2020 of over 88%. And our research department forecast on chart that EU plug-in EV sales in 2025 will be over 8 million. And this is definitely having an impact on cobalt demand, and definitely there is a focus on sustainable sourcing of this critical raw material as EU accelerates its transition to a greener economy and a greener mobility. I've also like to say that our research department forecast that global cobalt demand will reach 162,000 tons per year in 2022, compared with 120 tons per year in 2018. And a large part of this demand growth is due to the EV sector. So as we said, Europe is set to become a very large market for EVs by 2025. We have seen a resurgence of cobalt-free LFP batteries in China, but we think that cobalt-based battery chemistries will be a large part, will be a significant part of the European market. And also it is worth noting that so far the uptake of electric vehicles has been in cities where a shorter driving range is required, but the more the EVs start to spread around the world outside of China and, for example, in Europe, longer battery chemistry that support longer driving ranges that are more suitable also for the European driving styles, it means that demand for cobalt-based technology is expected to increase, and that's why Europe is so focused on the sourcing of these critical raw materials and its sustainability. And I would also like to pass it over to my colleague, Michael Greenfield, who will give you a better understanding of our take on the implication of the EU battery regulation proposal for the cobalt market. Michael, over to you.
Thank you there, Dalila. So as Dalila said, we're working on the premise that the high nickel, low cobalt battery will dominate or be prevalent in the European market, and that Europe will consume growing volumes of cobalt. So this makes regulation quite important, as initially we're dealing with some lengthy supply chains, and the regulations aimed at shortening those supply chains. Obviously, Europe is not blessed with these raw materials, abundant cobalt resources, and so the EU is building a framework to end the reliance on other countries. Cobalt often comes from remote locations, as we know in the DRC and such, and then shipped to Asia, processed, manufactured to a battery, and then moved into the European market, as you can see from the infographic there on your screen. So there's a high carbon footprint. The key issue that we're going to look at for the regulation is around recycling. So on the screen, you can see that there is a quota for a minimum content of recycled material. That's 12% of cobalt by 2030, and that moves up to 20% by 2035. So while this is an EU regulation, it's key because it applies to any battery in the European market, so regardless of where it's being produced. So this is regional legislation with a global impact. No evidence yet, it's quite early on, to suggest that this can become a global standard, although there are concerns from Chinese market participants whether there will be enough capacity, technology to recycle these volumes of cobalt. You can hear more about that on the next panel from our China session, hosted by our colleague Susan Zhu. According to the European Commission, global demand for batteries is set to increase 14-fold. And by 2030, EU could account for 17% of that demand. Although it's not yet tipped to impact cobalt supply in a significant way for some years, the EVs need to obviously hit the market, hit the road, be used, reach their end of life, and then the batteries can enter the secondary market. So this makes it obviously quite difficult to forecast how much this will impact the supply chain, this recycling quota. We can point to an interesting example with lead. So in 2020, we saw refined production is 11.7 million tons, but mine supply was only 4.5 million tons. So one benefit of Europe leaning towards a high nickel, low cobalt battery is that there's a high value of the raw materials which can be recruited from that battery. The LFP batteries, the material value is actually slightly lower, and I also understand that slightly it's more difficult to recover those materials. So ultimately, the aim of this regulation is that batteries placed in the EU market are sustainable, they could be collected, repurposed, recycled, and the true source of that, or the true value of that raw material, can be untapped, unleashed. But ultimately, key takeaway is that EV batteries need to get to the end of their lives in order to see cobalt coming from the recycling into the secondary market. So in the meantime, we do need cobalt from primary resources. So there we can see I'm moving on to look at traceable supply. And one initiative I want to highlight is the battery passport. Now, it's not an EU or European Commission initiative. It comes from the Global Battery Alliance, which is a World Economic Forum organization. But the battery passport, has been recognized and acknowledged and welcomed by the European Commission, although it doesn't officially form part of EU policy. It can complement the drive that the EU has for sustainable resourcing. So the passport will create an electronic ledger which tracks the material and will allow full traceability of the raw material from mine to car and onto the road. That will allow, obviously, more informed purchasing decisions from the industrials and the supply chain, and also the consumers at the end, purchasing the vehicles. It could also potentially facilitate artisanal product becoming a more integrated part of the market. We've seen the beginnings of this elsewhere in the market with the Gécamines Trafigura offtake deal. So by Fastmarket's forecast, mine supply is outstripped by demand in 2022 by 2,000 tons. And we've got a flat supply and demand balance this year. These forecasts include 15,000 tons of ASM material. So that indicates there's a big role for that material to play in bridging that gap. Otherwise, without it, we'd have a larger deficit. So currently we know that big companies in the supply chain like Umicore do not accept ASM material. And further downstream, we've got BMW, who completely circumvent the DRC with their supply deals. So resistance remains but it is these initiatives, such as the battery passport, which will bring visibility to the supply chain, allowing companies to make more informed purchasing decisions. So that brings a close to my presentation. Hopefully we've pulled together aspects of regulation, the impact on demand, purchasing decisions, and supply chain visibility. And with that, I would like to thank you all for listening and pass back to Mike Blakeney.
Thank you, Michael. That's a really interesting presentation, really interesting context for the discussion to come. I think it's clear from that demand for battery materials is growing, but that also creates the need for supply chains to adapt and make way for the future. I know Ms. Spiraki needs to leave at 11 a.m. for another appointment, so I apologise on her behalf if she's not able to answer your questions at the end, but we look forward to her speaking in the moment. In the meantime, I'm pleased to now hand over to Mattia Pellegrini, who is Head of Unit for the Waste Management and Secondary Materials team in DG in the Directorate for Growth in the EU. Many of you will know he's been absolutely essential to the creation of this battery regulation, and he probably knows more about it than almost anyone here. And so, Mattia, we're really interested to hear your thoughts on this, and so over to you.
Yes, good morning, everybody, and thank you for the kind words. Indeed, I would say 2020 for me was not only the COVID year, but it was also the batteries year, because I had to spend an enormous amount of my time on designing, together with a number of colleagues, this new piece of legislation. It has been a fascinating job. Of course, we are only at the beginning of the process, because indeed the co-legislator now will have to work with us to produce the new piece of final legislation. But the Commission proposal, as you know, was tabled at the end of last year, 2020. I just want to make a few points. So the first one, you may be aware that actually the batteries regulation was one of the few pieces of legislation which was clearly announced in the Green Deal with even a deadline. I think that's for a type of horizontal communication like the European Green Deal, to have a specific deadline, it was a sign of the importance of that proposal. Indeed, it was foreseen that the Commission should adopt by October 2020 a legislative proposal which will modernize the framework for batteries. So just to give you the challenge, we signed the contract for the impact assessment in February 2020. So that means that the full process of impact assessment and legislation was done in 10 months. That's for people which are familiar with Commission average time, where normally you have 2 years for an impact assessment and another 2 years for legislation. So you have between 3 to 4 years to develop a new legislation. We did what is done normally in 10 months. That means that we have been working honestly flat hours, including weekends, But at the end, we were very pleased. Of course, we didn't manage October because that would have been really a miracle, but we managed to produce a text before the end of the year. So by 2020, to stick to our commitment to come as soon as possible with a modernized framework. What I want to say about that framework, and then I will go what is really relevant for you as the cobalt industry. What I want to say is a few things. First of all, is the complete difference to what all the environmental legislation in the circular economy field, which has been done so far, for two reasons. One, it was the shift from a directive to a regulation. So normally, you may be familiar that the directive allows member states to take additional measures. Here we are in regulation because we're regulating a placement of a product into the market. So what is set in this regulation will be the final rules. So it will be an harmonized framework across the EU 27 member states. The second essential change was the transition from an environmental legal basis to an internal market legal basis. Why this is so important? You may believe this is more of interest to professor of European law. No, that is a major difference because that means if the requirements are set with an internal market legal basis, they cannot be changed by member states, while the environmental legal basis allow member states to go beyond. So imagine you have a mandatory recycled content like we have in the proposal, then if you don't have an internal market legal basis, potentially, I don't know, Sweden the day after could go with a different value on cobalt, or Denmark with a different one. You can imagine what type of disruption this will create in the internal market. So that is the first change. From a directive to a regulation, from an environmental legal basis to an internal market legal basis, which is, in my view, already on its own a revolution. The second big revolution is the fact that for the first time ever, we have taken the life of a product from the mining all the way down, not only to the first life and recycling, but even to the second life. You will see that there is an article specifically in the proposal also dealing with the second life of batteries, of industrial batteries, electric vehicles batteries. So this is, we are regulating also when a battery is coming to an end. As you know, a battery of an electric car, it can either go for recycling or it can also go for repurposing and remanufacturing. So they can be dismantled and used for energy storage. So we have regulated also that second life of the batteries. So that is also something which I would say has never been done. I'm saying this because because I was part of this group of colleagues which have worked on that, because indeed it's really the first time that you have. So from that point of view, the new batteries regulation is a prototype of the new product legislation, which is supposed to cover the entire life of a product. So not only the end of life, but also the production, the mining in this case of important minerals like cobalt, and until, as I said, the remanufacturing, repurposing of the batteries. And not to be forgotten that we have captured all type of batteries. So you may be aware that the whole batteries regulation, which was dealt by the environment, which was indeed, it was not a regulation, was a directive based on the environmental legal basis. It was essentially focusing on the small consumer batteries we use, all of us at home, while the new one is a major revolution because indeed it's going to look in all types of batteries of the future, from industrial batteries to electric vehicles batteries. So that's also the scope of this regulation has been changed. Now, if I move to three articles, which I think I draw the attention of which are the most relevant for you, for the cobalt industry. So the first one, indeed, is Article 39 of this regulation. By the way, this regulation is also a huge regulation, 78 articles and 14 annexes, and 36 pieces of secondary legislation. It's something, again, of a magnitude that, honestly, in 20 years working for the European Commission, I've seen rarely. So Article 39 deals with what Joachim, the director of DG Group, was mentioning, due diligence requirements, which applies also to cobalt. So cobalt is one of the materials or one of the minerals for which there will be an obligation to report on the respect of the due diligence obligation which are set out in Article 39. So there is an obligation to provide all relevant documentation to the suppliers. This is based on the OECD due diligence guidelines. So that Article 39 is of particular importance for you, and in particular needs to be read in conjunction with Annex 10. Annex 10 is the annex which defines what are the materials, so cobalt is one of them, and what are the risk categories. When I say risk categories, I'm referring to social and environmental risk. First article. The second one, very important for you also, and for the batteries industry, is the Article 8 on recycled content. There would be an obligation from 2030 to have a minimum level of recycled content of cobalt, because indeed, as some of the speakers were mentioning, we don't have many primary materials, and cobalt essentially comes from the Democratic Republic of Congo. So that's the reason why, in order to incentivize the recycling technologies, we have put two targets, one from 2030 and one from 2035, increasing target. And cobalt is one of the substances which is covered by this Article 8 in terms of mandatory recycled content. And final article, Article 57, which should be read in conjunction with Annex 12, which fits, again, as a total novelty. Not only there are recycling efficiencies, but there are also targets in terms of recovery of materials. These targets will apply, the first ones in 2026 and the second ones in 2030. And cobalt is one of the materials or minerals which is covered in terms of recovery of materials. So you will have obligation in terms of due diligence as cobalt industry, in terms of recovery of materials, and in terms of recycled content. Last but not least, I didn't plan to make that point, but it's an important point. So the previous speaker mentioned that the digital passport is not is something which has been developed privately and is not contained in this legislation. I just would like to correct that. I invite everybody to read this regulation. If I'm not wrong, I go by heart, it's Article 65. There is a clear provision in the batteries regulation which foreseen an obligation to develop a digital passport. So actually the digital passport is part of the batteries proposal. So I just wanted to clarify that in case that there are misunderstanding. Not only there is an obligation to develop a digital passport, so each of the operators will have to have a digital passport. There is also an additional obligation, which is the following article, which has to be linked with an electronic interchange platform, so which will be managed probably by the European Commission. So that's so also this transition towards the digital solution has been is contained in the proposal. So that's, I think, is the introductory remarks. I thought, and I've tried really to focus on what is at stake for the cobalt industry.
Thank you, Mattia. And that's I think that's a really interesting introduction to the work that you've been doing. And I think it's fair to say that the work you've been doing over the last year has been really world leading. And I know the audience who are from across the globe will be looking really interested, looking at that in a really interested way, because it's been very pioneering, and I expect it will have a big impact. You mentioned in your speech about working with the co-legislators and that being the next stage for this piece of regulation. And we're really pleased to have one of those co-legislators here on the panel with us today to share her thoughts directly. Maria Spiraki is a Greek MEP, and I think it's fair to say possibly one of the Parliament's leading lights on raw materials and batteries thinking. So we're really delighted to have you here today, Ms. Spiraki, and please, over to you.
Thank you. Thank you very much for having me in this very, very interesting meeting and debate. And I would like just to explain that I am here under my capacity as a rapporteur on behalf of the EPP in the ITRE committee. Well, I fully agree with Mr. Pellegrini. It is important for all of us to know that we are now facing a new piece of legislation, which is also a new modus operandi in terms of co-legislator. And I fully support this kind of approach, because we are now trying to work on the issue on how can we have batteries that are placed in the EU market and they are sustainable, they are high performing, and they are safe along their entire life cycle. And by saying this, I would like to focus on the issue of sustainability criteria and stand on the importance of the proposed regulation in the promotion of eco-design related and recycling content requirements, among others, in order to further close the loop in the battery value chain and promote circularity and sustainable practices. I fully support the mandatory requirement for recycling content in batteries, because I think that this will help creating a legislative framework which will support the objectives set by the European Green Deal the new Circular Economy Action Plan and the Europe's renewed industrial strategy. It is also important to listen to the concerns and to start working on the concerns of the producers in order to explain to them that the issue of the materials is important also, but we must not ignore the performance and the durability that the producers are raising. So we have to address their concern, but at the same time, we have to insist on provisions like mandatory recycled content, which is one of the key pillars of this legislation. Otherwise, we run the risk of increasing the amount of waste materials, and we run the risk of increasing also the lifetime emissions of the batteries, and that is something that we should avoid. And now I think that we have to focus on the real issue, which is the raw materials as such. And I think that we can all agree in this panel that we need to create transition pathways for our industrial ecosystems. Such pathways will offer a better bottom-up understanding of the scale of the cost of the long-term benefits and conditions of the required actions to accompany the twin transition, the green and digital transition we are all working on. And of course, we all know that we should give priority to the ecosystems and sectors that face the most important challenges in meeting climate change and sustainability goals. And these are the chemical, steel sector, and also construction. But however, batteries are a key component to the above sectors, as they are present and will become much more in the future in the production phase. In addition, batteries will catalyze the wider adoption of electromobility and will solve the problem of intermittent supply of renewables. And we have to enable investment, and by enabling investments in neutral and circular production, it requires robust demand for climate neutral and circular basic materials and the resulting final products. And by saying this, I would like to focus on the issue of data, because comparable data, non-embedded emission in upstream basic materials and intermediate productions are also essential, and I would like to underline it. Such data is essential for consumer-facing companies to reliably market cleaner products, and it's also critical that manufacturers are able to differentiate between high and low carbon materials from upstream suppliers. So we have a range of policies that we have to work on, and I would like just to give the topics of them. It is the unlocking abandonment incentives along the value chain. It is the improving product embedment, greenhouse gas data availability and comparability. It is also overcoming the market barriers that now facing on circular or innovative material, and it's also ensuring that this action is working in order to address the needs, and it is aligned throughout the whole value chain. In view of all this, I would like to insist on the issue that Commissioner Breton has already raised on how can we envision our role in the global market, and I fully support the approach that we have to lead the EU, to put the EU back on driving seat of the global motors. One of the flagship initiatives that we are working on, and I mentioned this yesterday in my intervention in the European Parliament when we discussed the industrial strategy, is the European Battery Innovation, and it is one of the most important projects of common interests that support research and innovation in the battery value chain. There are 12 member states, among which my country Greece, which will provide up to 2.9 billion in funding in the coming year. And this kind of investment will finally unlock an additional 9 billion of private investment. That is more than 3 times the public support. So we need more initiatives like this, and I think that it's one of the best practices that we have in our industrial strategy. I would like to conclude by saying that there are many important opportunities for us as policymakers to begin crafting a well-targeted package for policies to accelerate and foster lead market for climate neutral and circular materials during this period of legislative cycle. And the one we need is a pan-European industrial companies and value chains, harmonized policies, data and industry standards to invest in climate neutral solutions and business model. Because the main issue for me is how can we create a global level playing field for batteries based on sustainable materials and breakthrough technologies. By concluding, I believe that the proposed batteries regulation provides a solid framework for attaining a fourth amendment goal that I have already explained and objectives. We only have to be realistic in order to ensure that the outcomes of our efforts can be implemented and unlock the global market to the EU industry. Thank you very much for having me, and excuse me for the limited of time. Thank you.
No, and thank you very much, Ms. Riaki. We really, really appreciate your time, because I know you're very busy, and I think everyone will really, really value your thoughts on this. Recharge is one of the leading EU trade associations, or is the leading EU trade association for the rechargeable lithium-ion battery industry. And so perhaps more than any other organization or any other industry organization, their views will be essential for the Commission to consider. So Alina, we're really pleased to have you here with us today, and I'm sure everyone on the panel will be really interested to hear your thoughts.
Thank you very much, Mike. Thank you for the kind words. Thank you also to Cobalt Institute, obviously, for inviting me today to elaborate a little bit more on industry views on the proposed batteries regulation. And thank you also to my previous speakers for their, I think, more than interesting statements and many efforts also to link back to Matteo Pellegrini. The batteries regulation is indeed going to define, how Europe, but also non-European actors are designing, manufacturing, using, and disposing of, as a matter of fact, batteries, right? It has this unique potential, if you want, of translating the European Union's vision for batteries into a meaningful legislative framework. And I believe that the choice to go for a regulation, I also want to touch upon that point, is actually really key for having a meaningful framework. Now, on the objectives of the batteries regulation, I like to consider it to be the legislative answer, if you want, to the European Battery Alliance, as it was launched in 2017, right? With the dual mission of setting, on the one hand, a new sustainability standard in Europe, but I believe also worldwide, and at the very same time supporting the development, the establishment of a solid European battery ecosystem. Now, one thing I would like to stress here, despite indeed the many investments and in spite of the many announcements, the European battery value chain is an industry still in the making, right? Long-term international competitiveness, this is not yet a given. And I believe that the legislative support will be very pivotal for ensuring a level playing field and ensuring a sound, robust, and stable European ecosystem. It's also for that reason that I need to say that while we very much welcome the batteries regulation as it was proposed, it also features a rather high level of complexity and unfortunately also some overlaps. I want to mention one here, the introduction of the REACH-like restriction mechanism as we see it in Article 6 and 71. We believe that over all these overlaps and complexity, they risk maybe a little bit, jeopardizing the effectiveness of the batteries regulation. Having said so, we believe that the batteries regulation, fit for the future, right, and also fit for purpose, should really focus on creating additional benefits to the existing framework, because indeed we are not starting from scratch. And it obviously should ensure coherence with other pieces of legislation. And last but not least, to mention on this point, it also should continue to enable the development and the innovation potential of our industry. And two measures that I would like to mention that really can be considered as game changers are the carbon footprint and due diligence. We really applaud the Commission to have taken up these two pillars, because we believe that they are not only key to sustainability, but they are also key to ensuring and enabling a level playing field, right? Of course, if they are correctly implemented. We do have some recommendations on these points, right? And I would like to focus here now on the point of due diligence. And I believe that we cannot stress more that human, social, and labor rights, they are more than relevant, right? But they are relevant across the entire value chain. And that's why we also clearly want to see more in the batteries regulation on that very aspect. We believe that corporate responsibility, if you want, should not be limited to the raw material sector, but it also should include, what is taking place during manufacturing, what is happening during recycling, right? And especially in view of the still a very high number of imported final cells and modules. So we simply cannot neglect the manufacturing and the recycling phase if recycling is taking place outside of Europe. So to unlock the full steering potential of due diligence, we really think that the scope should be important. Now, coming to the end of my statement, let me say one last thing. Moving forward in the next step of establishing the European rules for batteries, I believe that it cannot be underestimated the role that industry has to play in the legislative framework. And simply because the technical expertise, the industrial experience, and also I believe the insights into trends, right, they really are pivotal to creating meaningful provisions. In the end, we are speaking of batteries, and we are speaking of an electrochemical energy storage device that is serving an increasing number of sectors and applications. And I believe it is important that the new EU rules, they really take into account the very, very technical specifics of batteries. Thank you very much, and I look forward to the Q&A session.
Thanks very much, Lena. I really appreciate your intervention there. Our next speaker is Jan Titkat, who's the Director of Government Affairs at Umicore. I think it's fair to say, Jan, that companies like Umicore will probably be at the heart of the system which this regulation is seeking to create, and the recycling work that you do will be an increasingly important part of the cobalt supply in Europe. So I think we'd be really interested to hear your views on this and to get your thoughts on batteries regulation.
Okay, thank you, Mike. Maybe our position in the batteries value chain. So Umicore is a producer of battery materials, cathode materials containing the cobalt, lithium, nickel, manganese. And we are also at the end of the battery value chain in taking back used batteries and to recycle them back to the building blocks to produce new battery materials. So from that perspective, I would like to make a few general remarks on the proposed battery regulation. And generally speaking, we would like to congratulate the Commission and the team of Mattia Pellegrini with the work that has been done. So we support fully the overarching objectives of the full Commission's proposal. So if we make some remarks, it's constructive remarks to make sure that the targets and the formulations in the battery regulation fit really with the overarching objectives. So if it is about responsible sourcing, or it is about CO2 footprint of the production of the value chain, we all support that. And but I would like to make a few remarks, as I said, constructive remarks to make maybe the proposal more fit with the objectives. Aline already said something about responsible sourcing, that we would like to see it expanded not only to the sourcing as such, but also to the full value chain. I would like to add even an additional layer on it. So the proposal of the Commission is limited to EV batteries and industrial batteries. I'm wondering why. Why do we not include just simply all batteries? I understand that, okay, in volumes, batteries for EVs and industrial batteries will be larger than batteries for electronics. But artisanal small mining, which could include child labor, if we would only focus on responsible sourcing for batteries for industrial and EV batteries, that, let's say, 10% could leak to the sector of the electronic batteries. So that's not what we want. There's not a moral difference between a battery for your smartphone and a battery for your electric vehicle. Moreover, the battery producing the same products, and either you are a responsible sourcer or you're not, and you will not set up two lines, one with battery materials responsibly sourced, and another line with battery materials which are not responsibly sourced. So it's not an additional effort for it's just simply broadening the scope to all batteries to avoid leakage of irresponsible sourced materials. Also in the manufacturing phase, so there is also on sourcing the recycled content targets. We understand that recycled content objectives come from recycling value chains where there is an issue with the market creation. We can understand that if you recycle paper or plastics, that the molecules that come out of the recycling process are not exactly the same as when you produce virgin paper and plastics. But and then the downstream users could have an issue with processing those recovered recycled materials. And so a top-down approach to force downstream users to use these recycled materials could be a good measure. But for the metals industry, let's be honest, a recycled cobalt atom or a virgin cobalt atom coming straight from the mines, you cannot see the difference. So the characteristics of a cobalt from recycling and a cobalt atom from a mine is exactly the same. So the market creation driver for recycled content for metals is not there. Maybe it's then for creating more recycling or better recycling, but for more, the quantity of recycling is driven by the collection. So the more you collect, the more you can recycle. And there we see we have the collection targets and for portable batteries and no leakage policy for industrial batteries and EV batteries. And I believe there we can do something better. What we can improve there is the end of use phase should be documented. There is the idea of the battery passport, but has been discussed already. So the end of the use phase should be registered so that we are sure which batteries are coming into the end of life management system. So that's one thing. And the other thing is that we can improve is that export of used batteries for recycling outside Europe, the current provision is that it has to happen under equivalent conditions, but those equivalent conditions are not specified. So we could say that not only recycling efficiency targets should be met, but that we also have to include environmental health and safety criteria to avoid that our waste would be exported and recycled in conditions which are not acceptable in Europe. So the amount, so the volume of recycling could be covered by existing measures like the collection targets and the no leakage policy. And then it's something about recycling quality. So there is indeed a certain risk with the current definitions of end of recycling, that there is a real risk of losses at the subsequent processes of refining or even downcycling. And when we're talking about, for instance, the lithium atoms as such, they could end up in artificial agglomerates so that they are not suited to be used in a battery again. So there we could work on the quality of recycling. So when is recycling finished? And so instead of having this pull mechanism of recycled content, we could achieve the same circular economy targets by the pushing objectives, the collection rates, and the recycling quality. And why would we prefer that push model, so the collection and the quality of recycling? Because the recycled content objectives are not a level playing field. So all batteries put on the European market have to comply with recycled content targets, but the European markets of recyclables, so the end-of-life batteries, is much smaller than the market of end-of-life batteries in Asia and in China. And moreover, there is much more production scrap in China and Korea. And so the access to recycled material for producers in China and Asia is higher. Moreover, they have not a domestic demand of recycled content, so they can easily allocate all the recycled content to batteries for export to Europe. So that makes that recycled content targets are not the same efforts for European or for non-European battery manufacturers. So that's why we prefer to achieve the circular economy targets or objectives rather by the push model, so the collection targets and quality of recycling, rather than at the pull side of the recycled content targets. So that's a few comments we would like to make, and again, it's from a constructive perspective that we say, okay, we support fully the objectives of the battery regulation, but we think that we can contribute by working on those provisions on the topics I have mentioned. Thank you.
Thank you very much, Jan. Really appreciate it. That's really useful intervention. So now we've got, I think, about 25 minutes for questions. I can see that a few have already come through the box at the bottom of your screen. The first one, and I'll direct this towards certain panelists just to try and keep things moving along and get through as many questions as we can. The first one is, what can the rest of the world learn from the battery regulation, and do we expect other jurisdictions to follow suit? I guess, Mattia, you probably can't count. Probably can't answer the second question about will other people follow suit, but perhaps you can let us know whether you think other parts of the world should take note and reflect it in their own regulations.
Yes, so I think it was also extremely interesting to listen to the other speakers. Also, please be aware that I have a meeting which has been convoked with my cabinet. I will tell you the hour because so I don't want to be. I think it's at. So I will tell you exactly when I will have to leave. I think it's at at 11:30. So, and I really have to attend. But about the rest of the world, so I can tell you that already some governments have been taking contact with us. So the first ones were the Canadians, which, for example, have approached us, and we had a very lengthy meeting recently where they wanted to understand how this framework was conceived. Also, you should be aware that this is a technical piece of legislation which is we are obliged to notify to the WTO TBT committee, which is a committee on technical barriers to trade. So that was notified on the day of adoption in December of last year, on the 10th of December. And in the meanwhile, we've got comments by Japan, by Korea, by United States, so by all the major producers of electric vehicles, essentially. And even more recently, actually yesterday, I was meeting with General Motors, so from United States. So several important producers from all over the world, they're contacting us. And they're asking, what about this legislation? What about having this as a global standard? Because indeed, it will make this is a global market, the one of especially of cars for electric vehicles and also for industrial batteries. So it would be very strange if we start to go for different values for recovery, different values for recycling, different values for due diligence, or different materials covered by due diligence. At the same time, so what I do believe is that, as you know, several times this has happened, and you mentioned actually in the introductory remarks, I have in mind two examples, the REACH, the chemical legislation, and also the ROS, the restriction on hazardous substances, which they became a model for, they were basically copied in the rest of the world. A few years ago, I remember a front page of The Economist, talking about the regulatory power of Brussels. So the Economist was saying that we're rather weak on the economic side, but we're very strong on the regulatory side. So I think, I don't want to prejudge what is going to happen, but indeed, from the contacts we're having both with governments and industry, it seems that there is an interest. There is also, as you mentioned, the Global Alliance on Batteries, which was mentioned by one of the previous speakers. So clearly there is a trend, and we have met several times with the Global Alliance on Batteries, and clearly they are also saying, for example, that the digital passport should be a similar passport which can be provided across the entire world. Of course, we can only regulate for Europe. So we did it first. So as you were mentioning in the introductory speech, we were the first mover in a very, let's say, innovative and advanced way. And what we've seen, what I'm extremely happy, That's something I forgot to mention, is that for the time being, no matter whether it's a EU producer or third country producers, in general, economic operators seems to be happy with the framework. Of course, the details, there needs to be, each of them has different comments, like Yumiko was saying, why you only cover electric car batteries and industrial batteries in terms of some of the articles and not consumer goods. So which is 10% of the market. The reason was for proportionality reasons. But of course, now the co-legislator can go in a different way, like Yumiko would say. But this is a matter of detail. The framework as such, it was welcomed by both all the economic operators and also NGOs, which is very rare. I can tell you that to see that on the same day of adoption, you have NGOs like Greenpeace or Friends of the Earth or Transport and Environment issuing press releases saying that the Commission has done a very modern piece of legislation. On the other side, heavy industry, starting with the European Batteries Alliance, doing the same. I think that's something which we should be proud. And of course, I really do hope that indeed that on our side, there is full willingness to cooperate. So Canada has contacted us. They wanted to better understand, to maybe inspire themselves. And we provided a very detailed explanation on all the different articles of the proposal. We are now providing written comments also to the questions asked by Japan, for example, in Korea, in the context of the WTO. And if there is a need of follow-up meetings with their countries, we will be more than happy to do it.
Great, thank you, Mr. Pellegrini. And perhaps I can actually bring in Michael and Dalila on that point as well, because I know you've got quite a global perspective on this. Is it something that you're seeing from your perspective that other countries are interested in this?
Thanks, Emma. Yes, I think it's still quite early to be kind of pinpointing an absolute trend on this. But yes, definitely, we're obviously expecting, if we've got China exporting a large amount of batteries to the European market, naturally they're going to have to start complying with the regulations. So that's very clear. At least some part of their production will have to fall into that. Now, whether, of course, that's an easier decision that they just go, well, actually, we can move our whole production line over to have meet these quotas, so that we know we're EU compliant regardless of what battery comes out of the line. That's a decision that they'll have to make. It sounds like from the other panelists, the gentleman from Unicor there, Jan, there's going to be an abundance of the secondary material available there in China. So it may well be that it's actually easier, cheaper, more cost effective to actually start complying with EU regulation, and that's a more beneficial system for them. And then they also, whether that battery is destined for EU markets or US markets, it really doesn't matter. And they've got a battery which is, efficient. It's going to do the job that it wants. It's going to have the driving range. It's going to have the charging capabilities and so forth. And that's ready to go, say, regardless of the end use destination or buyer or so forth. So yeah, as I say, bit too early for us, and I'm definitely not going to get the crystal ball out. But I think that gives an idea of what we're anticipating that we could potentially see.
Great. Thanks, Mike. Really appreciate it. Second question from the audience is, to what extent is recycling seen as the end goal for battery raw materials, for raw materials sourcing in Europe, and will it ever become self-sufficient for cobalt? I guess, Jan, that's probably well within your kind of purview. So I wonder if you have thoughts on that.
Yeah, two major remarks I would like to make here. First of all, we have to build a stock in the economy. And so with an exponential growth of use of batteries, we will not succeed to provide sufficient recycled materials in batteries for the next few decades. And so we will need to have primary sources to fill the funnel and to create a stock in the economy. And once that is done, in theory, you could say, well, if there's nothing changing, then you can turn the circle around. But this market of batteries is so dynamic. The composition of the batteries is so dynamic. And so if you look at the battery materials that we produce today compared to the battery materials that we produced 10 or 15 years ago, they are not the same. So it's quite possible that we will have a lot of metals coming back from recycled batteries, but maybe the need for those materials is not the same. And so there's dynamics that we do not know today, and that's one thing. A second element is also that we have to look how we can reduce the amount, the volume of materials in stock. And here I'm pleading, in fact, for all kind of models of car sharing. If you know that today only cars are used only 5% of the time, so 95% of the time cars and the batteries inside are idle, we should have the ambition to do better. So if we could drive a car 10% of the time, we could do the same with only 50% of the materials needed. So I think that saving materials, there is a large potential. And then people ask, but this is against your business model of producing materials. Well, then I add, no, it's not only about producing materials, it's also about recycling. And so if the cars are used more intensively, then they will not be end of life after 15 years, but maybe after 8 years. And then we will recycle them faster. But the amount of materials in stock, in the economic stock, will be just half of it. So I think this is two elements I would like to bring into this discussion. I don't know if other colleagues have something else to add.
Sorry, Alina, I don't know if you've got any particular thoughts on that. Do you think from your members that recycling is something they're looking to as a way of getting raw materials for their batteries in future, or do you think there'll still be a reliance on imported materials?
Yeah, can you hear me?
Yep.
Yes.
I mean, I just can mirror what Jan said. You know, we will never be able to just depend on one aspect or on the other aspect, right? It always has to be a good combination of primary and secondary raw materials. And indeed, I think when we are looking at the European market, we have to understand that, you know, recycling is still at the very beginning, right? The waste volumes are rather low, especially compared to other industries. And we have to understand that recycling is an industry that very much depends on volume, right? In order to be economically viable, but also environmentally viable, right? So I believe that we also have to understand these aspects. Now, when we are looking at the batteries regulation, we are obviously speaking of a more comprehensive system of circular economy, right? Recycling is only one part of that system. We also have repurposing, remanufacturing, and we will definitely need to see, you know, how these two pillars are actually going to work hand in hand, right? I just mentioned the waste volumes before that are critical to recycling. So we need to see, you know, how does the second life market, for example, impact positively or negatively that market.
Thanks, Alina. And another question, and it's an interesting one, and perhaps I can go back to you with this one as well. Could the batteries regulation potentially make electric vehicles more expensive in Europe?
And I guess, Mike, you're addressing that question to me?
Yes.
Yeah, okay, good. Well, you know, I don't know if it will impact EV batteries that much, right? But we do see a number of measures that do indeed entail a number of very serious administrative burdens, right? I mentioned before the REACH-like restriction mechanism on the one hand, but there are also other aspects, where you have to go through extensive verification, for example, right? And I don't know how small series or niche batteries, batteries that are produced in a very limited number per year, for example, how they are going to deal with these requirements, right? So I believe I cannot answer your question directly on the EV sector, but in general, I believe that we need to take a little bit into consideration that not every battery is produced like in mass production EV battery, right? And that not every chemistry is the chemistry that is built in millions, right? In million units per year. So I think this is the key point that I would like to pass on here.
Great, thank you. And in fact, actually, I've just seen a questions come through from Ernest Peraro, and I apologize if I pronounced your name wrong, who's from the DRC. So I thought it might be interesting to bring this to the panel's attention. How will the EU regulation work for sites where cobalt is mined. Can you assure us that companies will be able to follow those regulations? Perhaps, Mattia, I don't know, I can see you're still on the line. I'd be interested to know actually what your thoughts are on how obviously a lot of cobalt comes from the DRC. Will our will this regulation, what effect do you see it having on the DRC sourcing of cobalt?
Okay, so that will be my last intervention. Will also be an opportunity to wish you all the best for the rest of the day. And indeed, so as regards how this can work, there is a precedent. So you are probably aware that there is the EU was the first continent, also in this case, to regulate what are called conflict minerals, which indeed also the colleagues from the Democratic Republic of Congo are aware. At that time, it's an horizontal piece of legislation which imposed due diligence guidelines requirements on what are called the three T's, so tin, tungsten, and tantalum, and gold. So the scheme which we have for the batteries regulation on due diligence is very much similar to the one of the conflict minerals, with the only difference that the materials we are tackling are different. So they're cobalt or lithium or nickel and graphite. So these are the four, as you are probably aware, that they're covered. Why these specific four, which I didn't mention in my introductory remarks? Because these are the ones which, if you take batteries, the highest percentage of cobalt, lithium, graphite, and nickel will be found in batteries as a specific product. So it makes sense to be tackled in a specific sectorial piece of legislation. Now, how do we ensure that? As you have seen, we have done something more compared to the conflict mineral regulation. There will be an obligation of third-party verification. So actually to be compliant, you have to verify as third party your value chain. So that is what is considered innovative. And also, then how do we ensure that this is then when we get an import, because most of the time will be imports towards the European market, who is going to check? So this is also a novelty. You will, I invite you, all of you, to read the chapter on market surveillance. We have entrusted the market surveillance authorities of the 27 member states to do the compliance checks for the Commission. Why we have done that? We were able to do that because indeed the legislation is based on the internal market legal base. So we can give this task to market surveillance authorities of the internal market. So I would say it's the same scheme of the conflict mineral legislation, but with two important novelties. One, third-party verification, which will be important for all the operators which are importing cobalt. And secondly, inspections on the ground done by market surveillance authorities. And of course, the final aim of all of that is to make sure that conditions from a social and environmental point of view improves in all the countries from which the EU is importing this type of critical raw materials. And as I said, I wish all the best for the remaining day and discussion.
Thank you, Mr. Pellegrini. We really appreciate you giving us so much of your time today.
I would like to add a short comment. What Matthias said, it's about improvement and not about withdrawal. When we see that some companies announced that they will withdraw from the DRC, we do not believe that this is the best approach. So we have to learn from what happened in the past. We have to set objectives, what you would like to obtain, and work together on that roadmap, and not simply saying, we don't want any cobalt from the DRC. So I think it's something that we have to keep in mind.
Thank you, Jan. And I guess maybe just while we're on the subject, I'd be interested to know the views of the panel on the interconnections between the proposed supply chain due diligence requirements in the batteries regulation, and also what we expect to come from the EU, which is a sustainable corporate governance piece of legislation later this year. For those in the audience, these the difference between these is one applies only to batteries, and the other has similar but slightly different requirements, but much more broad, applying to all industry. I'm interested to know, while we're on the subject of responsible sourcing, what the panel thinks about that, and perhaps, I don't know, maybe Alina, maybe you'd be best placed to talk about that.
I mean, I just can reiterate our message, where we stand on the due diligence requirement, right? And I fully agree with also what Jan has said before, when we are speaking about extending the scope of due diligence, we are speaking on the one hand about the entire value chain. And maybe that is also a little bit of a shortcoming of, the other pieces of legislation that we see on due diligence, right? It always was very much focused on the raw materials side, right? But we have global value chains, and so much is still happening outside of Europe, and so we cannot neglect, the other steps as well, right? That's one point I want to make, and again, I want to mirror what Jan said before. We were then coming to batteries only. We obviously need to also make sure, that we have a level playing field among the battery types and chemistries, etc., right? So we also need to ensure that any battery model actually being placed on the market, has to comply with the same corporate responsibility requirements, right? Now, finalizing on my statement here, I believe that due diligence really has the greatest steering potential in all the articles that we see in the batteries regulation, right? In conjunction with the carbon footprint. But we really believe that it is key to sustainability, and sustainability, obviously, since we're also speaking about the European Green Deal, is pivotal. And then we also have the potential of due diligence as being really also a level playing field, right? It's also about ensuring competitiveness, right? If a European company has, so many things to comply with, we obviously also want to ensure that a non-European company has to comply with the same standards.
Mm-hmm. If I may add also a few words, when we compare the three major legislations on due diligence, so the conflict minerals, which has been mentioned already before, then the batteries regulation, and then later maybe this so-called horizontal due diligence legislation, we see kind of logic of expanding the scope. So the conflict minerals legislation was mainly focusing or exclusively focusing on human rights. It was not saying anything about environment, whereas the battery regulation expanded the scope to include also environmental, health and safety issues. And this new upcoming horizontal due diligence would also include governance, so money laundering, bribery, this kind of issues. So there's a logic. Another dimensional increase we see is that the conflict minerals legislation was really focusing on mining, on the real sourcing from the mines. Whereas, as Alina already pointed out, we would like to see that it's not only about the mining as such, but the value chain. And that's indeed a concept that we expect also in the upcoming horizontal due diligence, that is not just the source as such, but it's the whole value chain, and not only the end user, but also including the recycling.
Thanks, Jan. That's really interesting insights. And perhaps I'm conscious we're 3 minutes away from the end of the session, so I might just bring in Michael and Dalila just to see if you've got any final thoughts on this. I guess to wrap up the conversation, we've covered a lot of ground. We've talked about responsible sourcing. We've talked about how the regulation will impact global markets. I'd maybe just to finish things off, be interested to know what you both think will be the impact of this regulation on the global market. Do you see it affecting where supply comes from? Do you hear from people that you work with questions, comments, concerns about this regulation? I'd be interested. We've talked a lot about the EU, but if you have views from outside the EU, I think we'd be really interested to know that.
Yeah, I think there's some interesting issues around there, and I think there was a question a little while ago about would this make batteries more expensive? And of course, there theoretically could be a squeeze on the secondary market, making the recycled material, putting a premium on there or putting a supply shortage on secondary material. And if there's obviously a 2030 or a 2035 deadline for, your quota of material, that definitely could, cause some issues. And interestingly, we've actually seen a supply squeeze on recycled cobalt this year already because of COVID. So, industries that might take secondary cobalt, in the aerospace and so forth, there's not been a lot of that. And of course, you've got people playing in that market as well, traders who will see there might be an opportunity to hold on to that, take that material off the market and so forth. So that's one example of where we could see an issue. And I just thought I'd bring it back to that. So as I say, I think there's a big focus on China, kind of reiterating what I think has been said a little bit earlier, but I think that there's a big focus on China because obviously that's where most of the refining capacity is. How will they deal with this? How will they move over and adjust accordingly? And of course, then what do we see in terms of the supply chain, the value chain being developed in Europe? We know we've got battery plants coming online in Europe. They're coming into the market. Is that something that we see on a widespread scale? Will there be enough to cover demand, so on and so forth? And so I think there's quite a few issues to unpick there. So I'd like to cover that.
Great. Thank you, Michael. That's a really interesting way to finish the session. I'd just like to take this opportunity to thank Jan, Alina, Dalila, and Michael for your time. We really appreciate it and your brilliant insights that you brought to this panel. And Mr. Pellegrini and Ms. Berkey obviously had to drop off slightly early. They're very busy, so we completely understand. But we really appreciate their comments as well. And we hope that, I haven't managed to get through every question that was sent in to us, but I hope that covers a broad spread and people are broadly happy that their questions have been answered. So we've got in about 5 minutes time a panel specifically on China. We hope you'll stick around and join us for that. But in the meantime, we've got a 5-minute break just in case people need to get refreshments. But I'd just like to reiterate my thanks once again and appreciate your time.
Good afternoon or good evening. Thank you very much for participating in the Cobalt Institute panel discussion. We will speak primarily in Chinese, and we have provided simultaneous interpretation for your needs. So within the course of 45 minutes, we're going to talk about or look at an overview of the proposed EU battery regulations and the introduction of Chinese battery policy. My name is Susan Zhou. I am the moderator, and I'm very honored today to invite many experts from the industry to share with us their views. And we have invited Vicky Zhao. We have invited Zhejiang Huayu Cobalt representative, and we have invited CMOC, GEM Wuhan, Power Battery Recycling, Hunan Brunup, and the distinguished representatives of the industry. So to start, is it possible for you to address some of the issues of the proposed EU battery regulations and briefly introduce the battery policy in China? What are some of the future prospects for the battery value chain, and how will it affect the industry? Thank you. Sure. Now I would like to share with you a PowerPoint presentation on this topic. Good morning, good afternoon. My name is Vicky Zhao. I represent Fast Markets. Today I'm going to talk about an overview of the proposed EU battery regulations and a brief introduction of Chinese battery policy. As we are now focusing more on carbon neutrality and green energy, the Asian battery makers have sped up expansions in Europe. In 2030, it is proposed that the EU will have new energy cars up to 30 million. In order to meet the demands of the European market for electric cars, many Chinese companies, as well as Korean companies such as LG, SK Innovation, they've all set up plants in Europe in order to provide electric cars and to meet this demand. If we look at the development of the electric vehicles as well as the new battery regulations, in the EU in October of 20, the new battery regulation was proposed by the EU, and it will become effective as of January 1st, 2022. The new battery regulation focuses on the new requirements and repealing the old directives. So this will become effective in July 1st, 2023. And the new directive, or the new regulation rather, based on the old directives, have new requirements with regard to portable batteries, automotive batteries, industrial batteries, etc. And this also, of course, includes electric vehicle batteries. So based on the old requirements of the directive, new demands have been made on the supply chain of the entire battery life, the value chain, as well as the life cycle. And the new laws are more comprehensive and efficient. There will be restrictions on various issues such as hazardous substances. The definition of toxic and hazardous substances is proposed, and the restrictions and exemptions are updated, and new restrictions on toxic and hazardous substances are introduced. And of course, carbon footprint is an issue of great interest. the draft in the new battery law requires the development of a calculated carbon footprint for electric vehicle batteries with internal storage capacity. And there will also be specific classifications with regard to carbon emissions. The carbon footprint new regulation will be introduced in 2030, and industries will be required to follow the carbon footprint regulations and reveal and disclose its carbon footprint. And as well as this requires disclosure of the carbon footprint in the transportation of batteries. So this is all very new. And with regard to recycling efficiency, there's extended producer responsibility with regard to the responsibility of the recyclers. And in terms of the waste batteries, the collection as well as the transportation, the reuse, remanufacturing, and recycling, all of this is under the auspices of the extended producer responsibility. Furthermore, with regard to recycled content, by 2025, there will be new requirements with regard to the recycled content. So, for example, with cobalt, lead, nickel, and lithium, all of the contents in the waste batteries will need to be disclosed. And there will be a minimum requirement with regard to the recycling content. So on my chart, on my PPT, you can see by 2030, January 1st, cobalt will be about 12%, lead 85%, etc. With regard to the collection rates of portable batteries, there are also new regulations. So the collection rates at this by 2023 is 45%, and by 2025 it is 65%, and by 2030 this number will be raised to by 70%. And all batteries need to be recycled. And in terms of the recycling efficiency recovery, as far as I understand, these are technical requirements. So in terms of the weight of the batteries by 2025, the weight of the recycled of lithium ion battery will be 65%, and for lead acid battery, 75%. And in terms of recovery of materials, by January of 2026, cobalt the requirement is 90%. And you can see on my presentation all the numbers for the other substances. In the Chinese market, we are quite dynamic in terms of the recycling and recovery of materials. And with regard to the performance criteria, with regard to portable batteries, if the battery storage is more than 2 kilowatt hours, then in terms of the requirements, there will be, with regard to the chemical element of the batteries, as well as the storage content, the minimum age, storage period, durability, and anti-leakage. So after the regulation becomes effective, within 12 months, all batteries that the internal storage that is larger than 2 kilowatt hours will need to present the durability parameters as well as the technical standards. The new requirements has also requested by December 31st, 2030, the EU Commission will continue to get rid of the batteries that are no longer able to be, the portable batteries that no longer can be charged. And of course, there are also other safety requirements. By January 2026, the electronic exchange system needs to be established so that there will be for example, a battery passport, and there will be an avenue by which the producers can communicate this information in a public manner with regard to the type of batteries, where it's produced, and the dates, etc. And furthermore, requirements for supply chain due diligence includes information such as the cobalt, graphite, lithium, nickel, and other active materials for all batteries that can store 2 kilowatt hours or above. So the operators have a responsibility to provide supply chain due diligence, including the traceability as well as complying with regulatory rules. So here we are talking about not only the manufacturers, but also the importers and exporters. And there's also a responsibility to ensure corporate responsibilities, such as care for the environment, as well as care for the employees, etc. And so the due diligence need to provide proof, and third parties need to avail themselves to be audited. In other words, companies have an obligation as per the requirements of the EU member states to conduct third-party auditing. The new regulations from the EU are very comprehensive. By 2025, carbon neutrality should be realized. And in China, carbon neutrality should be realized by 2026. Now I would like to talk a little bit about China's EV battery policy and recycling. As of 2012, China has promulgated various rules and policies to guide the battery industry development and to support low carbon emission. So there are various management and industry standards, as well as safety and technique and performance regulations. So for the moving forward for the next few years, there's a need to strengthen and improve the standardized management of battery recycling, as well as maintain safety. So in this manner, we can ensure the highest level of efficiency rather. And we also further strengthen and improve the standardized management of battery recycling. China has also promulgated various policies with regard to battery recycling. So the responsibility of the manufacturers is enlarged. And from 2017 to 2020, there is also a new policy with regard to recycling batteries. And in 2020, as well as 2021, China Central Economic Working Commission has also strengthened the construction of a more robust battery recycling system. Currently, China is encouraging manufacturers and companies to remanufacture and recycle batteries. And China's cobalt recycling volume was around 12,000 tons, while global volume was around 19,000 tons.
After recovery and inspection, they can further be utilized, if passed, for household purposes. If they are not deemed suitable for repurposing, then they are recycled industrially. The materials are removed from them for reuse in the battery industry. There is a limit on the scrapping capacities for batteries right now, but according to our estimates, China's cobalt recycling volume was about 12,000 tons in 2020. Global volume was 19,000 in the same years. Given the global objective to achieve carbon neutrality, we have quite a long distance to cover. Thank you. Well, thank you very much, Vicky. And in your presentation, we note the complexity of the proposed EU regulations and new Chinese regulations in terms of sustainability and their strict requirements for that. Now, in 2030, there will be new obligatory requirements in the EU regulation, which will kick in. China started quite early in its work on using recycled material and building an industry that operates around that and a supply chain that operates around that. Now, what do you think has been some of the useful Chinese practical experience that is worthy of sharing at this point, and what issues and bottlenecks have appeared in China? We've seen the estimates for cobalt recycling in 2020, about 12,000 tons in China. Those were your figures. How many tons of those actually come from your members, and to what extent will China be in the position to fulfill the hard requirements on recycling, reuse, and production in 2030? Right, thank you very much. We were set up in 2015 at Hunan Brump, and we were authorized among the first batch of companies authorized to recycle cobalt by the MII in China. Now, we have two bases, one in Hunan for small electronic product recycling, and the other base is for power batteries, mainly for the dismantling of whole car power batteries. Now, we currently produce entirely on the basis of recycled cobalt rather than virgin cobalt. We have set up a demonstration product line on using batteries using recycled cobalt, and it should be in operation by next year. And we have initial plans in place for production with recycled cobalt in Europe. Now, cobalt recycling in China is guided by market principles, and it's in a world-leading position. Our recovery rate in the company has reached over 90%, including cobalt, copper, aluminium, and nickel. Now, in line with the goal of low carbon and efficient production, nickel, manganese, and cobalt from batteries have now moved into a circular production model. We have 419 patents which we have filed for recycling and production of batteries. Now, we recycle industrially and also at the end point from customer-provided materials. Now, the lifetime of a vehicle is 6 to 8 years, and the further time required for recycling and redeployment of its battery is about 1 year. Now, the level of end-of-use material recycling is still quite low, but our recycling of ternary precursor materials is quite high. Now, we expect the total quantity of cobalt recycled in China to be about 11,000 tons this year. There are about 10 enterprises of various sizes in China. It's a very active sector, and Hunan Brunp competes by means of its attractive pricing. Now, it's very difficult to set a realistic price for the recycling of cobalt batteries in China at the moment. It's seen as a cost rather than a value, but we provide a viable way forward for the recycling of cobalt batteries. Now, so far, there's no compulsory legal requirement on the disposal of vehicles, and in particular accountability for vehicle producers and other industrial producers on their responsibility for taking back the materials that they've produced in China. There's at the moment a legal vacuum in China in this respect, and there are quite limited avenues for achieving recycling of these materials. And we look to the government and the public sector more generally to set up a framework for this to be achieved. Now, we hope that there will be a transparent management of the whole value chain from production right up to cascading and recycling. And with improved conceptual understanding of the environmental effects of recycling, progress can be made. Now, in industrial recycling, we have promoted green and ecological concepts of recycling. Last year, we read that the emission requirements, the fleet emission requirements, will be reduced further in the European Union by 2030. And there is provision for potential subsidies of 6,000 euro, 50,000 RMB per vehicle if they meet the corresponding environmental requirements. So given this pincer of toughened emission requirements and targeted subsidies, we expect to be in a very good position to supply the European market, which would be at least 1.8 million vehicles per year. Now, in Europe, there is already small-scale use of recycled materials. We expect there to be 30% growth in the European NEV market per year, and also the market share of NEVs in the car market will continue to rise in advance of the entry into force of the regulation 2030. We think it will reach 12% or higher. Now, in terms of supplier capacity and social responsibility, it has now been regulated that every car manufacturer has to have the capacity and avenues to provide for recovery. And we have at Hunan Brunp the conditions to make this a viable prospect for European producers. That was just a brief rundown of Hunan Brunp. Well, thank you very much. And I think much of what you're talking about is a common objective, reducing carbon emissions and so on. As you do point out, however, there needs to be further standardization in China to achieve this. Now, Mr. Zhang from GEM, you started recycling operations quite early. Now, Tina mentioned just now that the overall value chain or the supply chain in China has a number of issues that need to be dealt with. The total recycling of NEVs is low, and the avenues, the mechanisms are not very developed. Supervision is not transparent enough, and so on. But in overall terms, the current situation is that China is not yet in a position to meet the requirements of the EU regulation in 2030. Now, talking to Mr. Xu last year, he mentioned that GEM had a plan to set up industrial parks in Europe to offer more of a circular mode of production. Now, like Tina, and she has also mentioned that they've set up a demonstration line in Indonesia, and said that they will be doing similar things in the European Union. I'd like to ask you now, at GEM, how do you see the prospects for Chinese companies expanding out of Europe to enable more a circular mode of production and use? I mean, you have a pilot project in operation. What are some of the lessons for you and problems you've encountered in that pilot project? And what further steps do you have in the pipeline? Thank you. Right. Thank you. Well, that was quite a lot of questions, not just one. Distinguished colleagues, and you are colleagues and very distinguished, I am generally quite optimistic about this issue. It's not going to be solved overnight. We've only been in existence as an industry since 2013, much less time than internal combustion vehicles, but the technical leaps that we have made and the acceptance by government and society have progressed very, very fast. And that's a function of the technical progress that we've achieved. Now, secondly, will the rate of recovery in China of various metals reach the percentages stipulated in the European regulation, 12% or 15%? Last year in China, we had a market of 1.38 million NEVs in China. In 2025, we will have it up to about 5 million. And by 2030, I expect the total fleet to be at least 15 million vehicles. That's just an idea of the growth trajectory that's happened. And if we assume that usage life is 8 to 12 years, then we are in a position to achieve full recycling. Now, this year we have 500,000 new vehicles being sold. So if you add those to the vehicles currently on the road, that brings us up to 1.5 million plus in China. Now, we just have to solve the following questions. Firstly, how do we get them all back? Secondly, we have a 5-2-5 or a 6-2-2 technical system. And in future, it's going to be an 8-1-1 system. So you're going to see increasingly low demand for internal combustion vehicles.
As our technology grows, of course, there will be many changes. So can we ensure that we can recycle 100% that is something that we're looking at, that we can meet the requirements of 2030. And we believe by 2030, we will probably peak in terms of the number of electric vehicles that are produced. So this will definitely have an impact on battery. So by then, perhaps we can achieve a real sense of the recycling economy. So in fact, I am quite optimistic about the future. And how can we ensure a high efficiency in terms of recycling? I think the current policy is not enough. What we have seen is that the government has been revising the policy from 2018. So, in fact, with the new amendments, we will be able to fulfill our obligations and responsibilities with regard to increasing the efficiency of battery recycling. And this is going to, of course, impose a certain amount of impact on the development of the enterprise. And of course, as we mentioned earlier, various industries, various enterprises will be affected by this trend for recycling. And currently, we're looking at quite expensive, in terms of the price of batteries is still quite expensive. So in the future, if we can use market mechanisms to decrease the price and then to increase the efficiency of the recycling, in fact, I do believe that the future looks very optimistic, and we can achieve the level of efficiency that we have in mind. But currently, we're still not quite there. And so we need to maintain a certain value gauge to look at how the market is evolving. And in the future, the new batteries, the difference between the cost and the price on the market will not be that big. And then we can also ensure a higher recycling rate for the new batteries. So that's my answer to your first question. So in terms of the international landscape, what do you think about how foreign governments are looking at China? So are there particular things that the Chinese manufacturers need to pay attention to when looking at the global market? First of all, we know that recycling it is very important in various markets. So not only in China, because this is part of what would contribute to better life for all of us, a better environment. Now in China, the various industries or the enterprises are sharing experiences, and we are doing the same thing with our international partners. So at this point, we can see that people are addressing the issue of recycling, of protecting our environment. So this aim or this objective is concurrent both in China and overseas. So currently we are working in Korea and Indonesia, and we are also recycling batteries overseas. So I think if we look at the statistics from last year, in Western Europe, we will see that they are going to sell more electric vehicles, more so than in China even. And I feel very positive about the Western European market because in Western Europe, there's a stronger awareness or focus on environmental protection. And from every country we could look at in the EU, they are implementing policies, promulgating policies with regard to recycling and to concomitantly environmental protection. So I do believe the market in Eastern Europe looks extremely promising. Now we are partners, as you mentioned earlier, for example, CATL, one of our partners, and as well as other partners, they have plans, they have sites in Europe, and the new EU regulations are actually the new regulations have imposed responsibility on the manufacturers, and this is something that we welcome. So if we can provide the battery plants in Europe any type of service and to help the EU in terms of providing the necessary minerals, to necessary raw materials, I think this is something that is very positive for all sides. So I do believe the current environment is a much more positive one. But of course, having said this, we need to understand in terms of how we interpret the policies. We need to understand what the policies aim to do. So we want to compete in harmony and not compete against each other. So we hope the R&D institutions, organizations can also help us in terms of researching and developing new technology around recycling. So together we can provide the best service, or it help together to improve the environment for battery recycling. So this is why I'm very, very pleased to participate in today's panel. Thank you very much for your views. You mentioned earlier, because we're using recycled cobalt, this has created an impact on the demand for cobalt in the market. So from the perspective of resources, how you still have quite a lot of cobalt in your reservoir. So can you tell us a little bit what you think will happen to the need for cobalt with the increased use of recycled cobalt? Okay, thank you very much for your question. First of all, as an upstream company, as a responsible enterprise, we of course support any form of recycling as part of the circular economy. And this is very positive, not only for GDP development, but also for the development of a better environment, better planet. China has been very, very resolute and clear in terms of our support for environmental policies to protect the environment. So the development of circular economy is very important for the development of new energies. Furthermore, when we talk about cobalt, especially for an upstream company like us, we must not forget that in most circumstances, it's a semi-produced product. So it is very closely linked to environmental protection. So as an upstream company, in terms of mid and long-term development, we are very, very optimistic. And in terms of the recycled cobalt and the circular use or recycled use of cobalt, we are very positive about this development. We don't feel that it has had a negative impact on our business whatsoever. And in the near period, in the short term, we are still actively investing in cobalt. Thirdly, in terms of the responsible provision of cobalt, or cobalt supply, I believe that we have reached consensus on what is the right way forward and what are the relevant standards that we need to comply with. So I believe we are all moving in the same direction. with regard to recycled cobalt. So as we said earlier, we need to be able to ensure that the cobalt is sourced responsibly, ethically. So it is my hope that we need to work together to ensure the healthy development of the cobalt industry. We are not each other's enemies. We are not competitors. We are collaborators. Thank you very much. As you mentioned, the importance of sourcing cobalt, as Vicky mentioned earlier in her presentation, that it's important to ensure responsible supply chain. In the last few years, we've seen Chinese enterprises working very hard at ensuring a responsible supply chain. And of course, there have been many initiatives both in China as well as internationally to ensure this responsible supply chain. So I would like to give the floor to Bryce to hear what your views are about the market, about what is a responsible supply chain and responsible sourcing. So from the upstream to the downstream. And I know that you've worked very hard on this in the last 5 to 6 years. What do you feel is something that deserves to be shared? In other words, your best practices or your experiences, and moving forward, what should be further improved? Okay, thank you very much. First of all, I would like to thank the Cobalt Institute for inviting me to participate in this panel discussion. As we heard about the EU's new regulations on battery and also the importance of ethical and responsible sourcing of cobalt. Now, this is an issue that is of great interest to me. Now, to answer Susan's question, I would like to talk a little bit about the development in the last few years and the challenges that we have encountered. In 2016, I was transferred to the corporate social responsibility department, and I became solely responsible for the company's social responsibility. And in the development of the battery policies, it was very important to us to attach importance to sustainable development, the sustainability of the minerals and the sustainability of the recycling. So let's talk about cobalt to begin with, because there are many other raw materials. Currently, we have achieved a lot of results in terms of our in terms of cobalt. So that's something we are very proud of. From 2016, as I mentioned, we have established a special CSR department, and in 2017, we established the specific system to manage cobalt and to analyze the environmental issues as well as human rights issues related to cobalt. And so we created a platform for stakeholders to communicate with each other. This goes to show that at the time, the system was operating under the Chinese system, so where we also focus on cobalt as well as the minerals that were sourced from the Congo, and to understand the mines. And of course, we participated in the training of the employees, of the workers at the mines. So within this industry, we worked very hard in ensuring CSR.
Furthermore, by involvement in RCI, GBA, and other industry initiatives, we have shared our experience with a broader audience and presented it, in fact, at various international conferences and we've been very transparent about our experience and also difficulties in the cobalt supply chain, because that's the only way to gain trust and get people to take the actual issues seriously. We have a provisional due diligence standard for cobalt refineries as a result of our involvement in RCI and GBA. I mean, it's just a provisional standard at the moment. It's not yet a final standard. Huayou Cobalt has been very clear from the beginning in supply chain management. We have to look at the issues behind media reports of problems such as child labor and other issues. So we were the earliest to set out key principles for due diligence and functional division between the basic refineries in Congo-Kinshasa and the fine refineries in China, and we set out specific due diligence concepts for them. And we also made our due diligence web go into some detail at the level of the societies it was in. And there are different types of cobalt mines, open and deep mines, and we tried as far as possible to eliminate supply chain difficulties and issues from the origin, and that has been a result also of our involvement in things like the Responsible Cobalt Initiative and other international initiatives. Now, we have made a lot of progress, and I hope we've managed to make our own contribution in setting up cobalt supply chain management as a reference example for industries. Now, for the future, we need not only to refine the standards, but also look at issues that standards can't deal with. We mustn't set the goal too high for standards where it's unfeasible. Secondly, there should be an objective and predictable framework for how companies can achieve 100% compliance with the standards. I mean, otherwise it's like requiring every primary school student to get full marks every time. No, they're not going to do that, but they have to know how to get there. Thirdly, the standards for management of refineries and mines are too high, and many of the specific points are unattainable when you look at the very upstream of the supply chain. Fourthly, in the mid to lower reaches of the supply chain, I mean, a lot of attention is paid to the upstream part of the supply chain, but a lot of the crux of the issue is in the mid to lower reaches of the supply chain. Thank you. Well, thanks, Bryce. Now, you've talked about the tough requirements in supply chain management terms for Huayou and its downstream partners. I will just take the conclusion that we need to have more attention paid and more viable standards for the upstream parts, especially basic refineries, primary refineries. Now, I'd like to ask you, as an upstream producer, how do you see the issues that Bryce has just been talking about? You have the mic. Julie. Susan, could you just repeat the question, because my connection was patchy just then. All right. Well, Bryce has talked about accountability for the whole supply chain for cobalt, but most of the focus, most of the attention is on the mid to lower reaches of the supply chain. And he says that there ought to be more attention paid to the upstream section, primary refining in particular. Now, in the mining sector and the upstream sector, how do you see this? All right, thank you. Well, for the upstream, for mines, due diligence standards and CSR are already fairly certain and predictable. So we are working on some disclosure and auditing efforts at the moment for the upstream sector. Now, public opinion seems to have certain prejudices about the cobalt industry, whether it's the upstream, the mines, or refineries. We've actually been making a lot of effort to improve conditions in the supply chain, not much of which has been taken into account, in particular when it comes to the upstream segments, mines and primary refining. So we shouldn't point fingers at each other straight away. We should work to improve the image, the reputation of the whole industry. So we should work together as an industry on that. And as has been mentioned just now, the colleague from Brunp and others mentioned that there's been a lot of development, of evolution in the upstream sector, and we need to make sure that all participants, all stakeholders in the sector are singing from the same hymn sheet here. Otherwise, we face the danger of cobalt being replaced by other materials. So we need to use the voice that we have, bringing different parts of the supply chain together. Not just our voice, in fact, but we also need to use the voices of the public, the government, and NGOs, and downstream customers. So we mustn't just look at condemning, the risks and dangers in the cobalt supply chain. A lot of the dangers in the supply chain for cobalt are just a reflection of the socioeconomic state of the place they're in. They're not specific to this industry. Overemphasis of the risks and dangers results in a risk-averse approach by business. And their due diligence may lead them to not using cobalt at all. The victims of that will not just be the cobalt mines, but also the communities that they're situated in, the whole areas that they're situated in. So we have to have our part in the conversation to encourage a rational approach to risks and risk management and mitigation rather than total risk avoidance. Thank you very much. Thank you, Julie. And in common with Bryce, I think you're telling us that the whole supply chain has to work together and not just adopt a passive stance when it comes to standards you have to meet. Now, let's see if Tina and Zhangpeng would like to answer this question that I've had come in. Currently in China, is there a relevant supervision mechanism to determine the actual state of recycled cobalt usage in batteries in China at the moment? Is there such a mechanism in place in China right now? Mr. Zhang, as far as you know, does the current Chinese framework have something like the new EU regulations policy of quantitative reporting on the amount of recycled cobalt? Well, last year was the start of cobalt recycling for us in China. So the levels are quite low, limited right now. In policy terms, there is not yet a hard requirement of the quantities or the percentages you have to use of recycled cobalt. I'm sure that there will be, but as far as I know, I don't know if other people want to come in on this point, but as far as I know, there isn't such a policy right now. Tina, have you heard anything about China's having any plans to set up such a mechanism for minimum recycling levels in batteries? Well, currently there is no legal requirement for levels of recycled material. Car and electronic manufacturers are certainly encouraged to use more recycled cobalt. So it's been promotional, directed towards them. But in institutional or regulatory terms, so far, they have not set down any hard requirements for usage rate of recycled materials. All right, now I haven't seen any other questions come in from the audience yet. So given that time is coming to a close, I'd like to thank you, all five of you, very much for your presentation of the impact of the new EU regulations and the state of the industry in China and beyond right now. I would now like to hand over to Mike to make a couple of housekeeping announcements. Mike, I will hand over to you at this point.
Hi, thank you very much. And thanks everybody for that really, really interesting session. I think I certainly learned a lot from it, and I'm sure many of our listeners did as well. Just to let you know, we're transitioning to a lunch break now. So we'll be back in about an hour's time. If you would like to join us at 1:17 precisely, we're, as part of that lunch break, going to show a couple of our members' videos, which might be interesting to a few people, but that's non-compulsory. So we will be returning next for the session on cobalt chemicals management and impact on batteries at 1:25. But you're welcome to join us for those videos a bit sooner. But otherwise, thank you very much for your time, everybody. I thought that session was absolutely fascinating, and I hope everyone has a nice lunch. Thank you.
Those who aren't in the cobalt industry view cobalt through the lens of child labour. But the vast proportion of cobalt produced in the DRC is not even connected to this. It's correcting that perception to ensure that the people of the DRC can prosper as a country, as a region.
With cobalt, we have a real opportunity because cobalt is a critical mineral in the e-mobility space that is essential in the climate change agenda.
What we are looking for is that together as an industry, we create the framework of what does good cobalt look like, open our supply chains to bring it to the markets, and at the same time take the responsibility to invest in it and to find the right systemic solutions.
Glencore is playing a lead role in trying to set up the way cobalt should be produced and marketed. We want to make sure that those minerals are produced in a very responsible way and a sustainable way.
As a leading cobalt mining company in DRC and in the world, we do represent hope. We're part of a community, and what we do is for our people in our community.
Nous faisons la construction des écoles, la construction des centres de santé et aussi le forage d'eau potable. Nous avons les projets de développement local. C'est là où nous trouvons des activités telles que le moyen de subsistance durable.
Déjà ça vile na mimi comme chaque na carrière tena ikuwe na avenir. Il y a des risques na de retrouver bana invité ku synergie ya KCC. Pale bana tuonesha banasema bon kama mnafanya association anasema amiapuye ndio kutoka kwa carrière mcréer une alternative nyingine.
Dans le futur, nous pensons que toute la communauté aurait leur façon de vivre dans le développement et que dans ce sens, eux-mêmes seraient indépendants de la compagnie.
So it's an 11,000 workforce business, and most of those are from our community. People see us as companies that can offer jobs, good salaries.
Our people, our strength. So safety is our first priority here at KCC.
When we onboard people, we have specific induction. What is the hazard they will be exposed?
Anyone at all has the right to stop something that is unsafe. Anything that cannot be done safely will not be done.
There are a lot of things we are doing on the environmental side to make sure that we can actually run a sustainable operation.
At KCC, we are mining cobalt. We are doing so with renewable energy, which is hydropower.
Ce qui est de l'eau, nous avons un projet qui est en train de travailler sur la récupération de tous les overflows que nous avons un peu partout à l'usine et retravailler et remettre ça dans le process.
The key thing for us is making sure that we're doing preventative maintenance, making sure you keep the process material within the plant itself.
Nous ne pouvons qu'être fiers parce que nous savons que nous protégeons des vies, parce que nous protégeons notre environnement.
The cobalt industry has definitely taken huge strides forward in the past few years to engage with some of the most pressing issues around cobalt, particularly relating to artisanal and small-scale mining in initiatives like the Fair Cobalt Alliance, the Cobalt Action Partnership, and others.
Being involved in discussions about responsible sourcing and sustainability, it is exciting. The society and our stakeholders will watch us carefully and they expect results. And so we have a duty to succeed.
Whether you're pushing your boundaries to get to new heights or just feeling inspired and free, energy runs through all our lives. It's what connects us. Do you remember landing your very first job? Well, we were there. When you were pushing yourself to the limit, we were there. The moment you wished you were there, but had other responsibilities, we were there to help you out. When your decision to store energy at home meant the beginning of a beautiful friendship, we were right there. You can't see us, but we are at your side today and tomorrow, at the biggest moments in life, as well as the small ones. Life needs energy. We provide it. We are Umicore, a global leader in the production of cathode materials. They determine the performance of your rechargeable lithium-ion batteries, how long you can talk over the phone, how far your electric car takes you, and how much energy you can store from your solar panels. We are unique in our business. In our R&D centers in Europe and Asia, we continuously design and test cutting-edge battery material technologies. We were the first to get a third-party recognition for using ethically sourced cobalt in our products. We have more than 20 years of expertise producing the best battery materials. We manufacture our products in line with the highest industry standards. And we close the loop. When you have no more use for the battery, we recycle the raw materials such as cobalt, copper, lithium and nickel, so that they can be used again in new lithium-ion batteries. Powering your life sustainably. Umicore. Materials for a better life.
Toxicology and regulatory experts who are always there to help the Cobalt Institute members in complying with a mysterious world of chemicals management laws. I'm here to take you through an engaging discussion, a discussion about the safe use of cobalt. In other words, we are entering the chemicals management dimension of the regulatory world cobalt is part of. Previous sessions of this conference have addressed cobalt availability, price influences, and responsible sourcing aspects, amongst others. All these are close to the hearts of varying stakeholders of the cobalt value chain and the Cobalt Institute. Chemicals management and cobalt safety is what completes a list of challenges that front-running and responsible producers and users of cobalt have at breakfast every morning. Whereas we can all agree that the production and use of cobalt should be done safely, demonstrating this may in practice resemble more an obstacle course or trying to leave the Minotaur's maze. And let me tell you that achieving these needs much more resources than just a ball of string. With the quality of speakers and panelists in this session, let's try to transform the obstacle course into a relay race. In this race, all stakeholders have a role to play to make sure we find our way through one of the most interwoven systems, the chemicals management labyrinth. In order to describe part of this labyrinth, please allow me to welcome Ms. Veronica Lesso, Policy Officer of the Director General for Growth of the European Commission, who will be involved in the revision of the very famous European REACH regulation, for which a proposal is expected in 2022. Veronica, many thanks for having accepted our invitation, and the floor is yours.
Thank you very much, Caroline, and good afternoon to everyone. First of all, thank you very much for your invitation to this conference. And I'm very happy to contribute to it and to learn from the discussions of today. So I'm supposed to give you a short introduction on the ongoing work of the chemical strategy and what it may entail in terms of changes to the chemicals management legislation landscape in general, but also in particular in affecting the battery technologies. So you are all aware that cobalt is a carcinogenic substance, category B substance. And for this reason, it was identified as a substance of very high concern, an SVHC, and included into the candidate list of REACH. Well, in its more than 10 years of history, first 5 cobalt salts were identified to be included in the list of substances that are subject to authorization, meaning that included in the Annex 14 of REACH. But then later, in 2017, the Commission requested ECHA to prepare a restriction dossier for the 5 cobalt salts. Of the RAC and SEAC was received by the Commission early this year in January. And the RAC final opinion, although it supported the restriction targeted only at the 5 cobalt salts, but more importantly, it strongly recommended establishing a binding OEL for cobalt as a metal and also for all its salts. Well, a binding OEL would regulate the exposure to cobalt in its metallic form, which is, for example, present at the recycling facilities, and also cobalt salts which are present in the workplace. So it's a much broader scope than a restriction would go about. Then the socioeconomic team, SEAC, concluded that there is an uncertainty whether a restriction is the most appropriate EU-wide measure due to proportionality aspects, the limitation of the restriction of 5 specific substances, and the discussion whether a binding OEL would be a more appropriate risk management measure. We also heard from industry, from you, that also it was considered that the binding OEL would be the most suitable risk management measure for reducing the exposure to cobalt and cobalt salts in the workplace. So the good news is that it's being proposed also and discussed in depth internally, and in all likelihood, DG Employment will work on it, and that means that this will allow us to close the restriction. So we will shift it over to the OSH legislation. Now, coming to the chemical strategy for sustainability, as you know, the EU has adopted the chemical strategy in October last year. And the strategy aims to increase the protection of human health and environment against the hazardous chemicals and to boost innovation for safe and sustainable chemicals. It is part of the EU zero pollution ambition, and that is a key commitment of the European Green Deal. Now, the chemical strategy brings on the table a reform to the restriction process, as it was identified that the current restriction process is actually too slow to sufficiently protect consumers and professional users against risks from the most hazardous substances. The normal restriction procedure through specific risk assessment puts a high burden on authorities to document unacceptable risk for health or the environment. And although REACH already enshrines the use of a generic approach for restricting certain CMR substances in consumer products, this procedure cannot be used for other critical hazard classes, including endocrine disruptors, PBTs, VPVB substances, immunotoxicants, neurotoxicants, etc. Moreover, the professional users are often using the same products as consumers, but much more frequently and during a much longer period of time. Yet they are unlikely to benefit from the same risk management as in an industrial setting. Therefore, they should get a level of protection at least at the level of consumers. So the chemical strategy is putting a few options on the table in terms of reforming the restriction. So firstly, by extending the generic risk approach to restrictions to endocrine disruptors and the other substances that I mentioned before. Also extending the generic risk approach to products marketed for professional use, so to self-employed who are not covered by the OSH legislation. And thirdly, to operationalizing the concept of essential use in restrictions, including the criteria for granting derogations. This extension of the general risk approach will be evaluated in impact assessments. The inception impact assessment to implement this approach in REACH has been published recently, and it's now open for comments by the 1st of June 2021. But in 1 minute, I will come to you again with the timeline, the exact timeline. So coming to the essential use concept, where such hazardous substances are proven to be essential for society, the derogation will remain possible and will be assessed on a case-by-case basis. Now, this essential uses concept starts from the idea that where the most hazardous substances are needed by the society, we need to be faster in substituting them. However, the concept of essential uses also recognizes that hazardous chemicals may have a very important role to play in applications with an important societal value, for example, health protection, including protective equipment, but also technologies for climate neutrality, etc. So in other words, the aim is to ensure that the most harmful substances are only allowed if their use is still very necessary and critical for the functioning of the society, and there are no acceptable alternatives exist at the moment. So in this context, the first discussion took place already in the REACH context. We had 2 Caracal discussions about that. But the Commission is now looking into how to extend the discussions beyond REACH. And the DG Environment will soon launch a study on this topic, and we will organize a first workshop with broad stakeholder participation. So what the chemical strategy tells us is that we will have to define criteria on this concept, but this will not be straightforward. Setting up a criteria will require a lot of discussions at various levels. And one can imagine that when we extrapolate from the Montreal Protocol, the situation becomes really, really complex. For the non-essential sectors, of course, a solution should be found. So, of course, for a certain amount of time, they can be most likely continued. But yeah, so the idea is that if it's not essential use, then it has to be banned. So we are looking ahead, a lot of discussions. And I have to say that the impact assessment will determine what do we do with the essential uses. But obviously, cobalt is a very, very strong candidate. And we are all aware that many, many applications are highly beneficial for the society. So actually, I'm not worried for cobalt in that sense to be ranked as essential or not. And finally, in terms of the timing of the impact assessment that I mentioned to you, so we have recently launched it in the beginning of this month, the Inception impact assessment. So this is now out for commenting. There is a Commission's Have Your Say portal, and this is where we are waiting for and expecting comments by the 1st of June. So everybody is very, very welcome and invited to comment already here. But there will be other occasions as well. So as I also mentioned, we will launch studies on essential uses and the general risk approach and revising the authorization and restriction system. In the first quarter of next year, there will be an open public consultation. There will be a possibility to comment again. And as Caroline mentioned already in the beginning, the Commission is planning to adopt a REACH revision proposal at the end of 2022. Now, we know that this is a very ambitious timeline, but nevertheless, it's urgent and we are very committed to work towards these deadlines. Maybe for cobalt, there is not too much to be changed. We may extend cobalt further to articles, but cobalt in batteries will remain essential, as I just mentioned. But obviously, the idea is that wherever there is a possibility to substitute, it should be substituted. So we still want industry to look for alternatives, and then the derogation will be cancelled. But we, our society, have a high need for batteries, and that will not work without cobalt, I believe. So thank you very much for your attention.
Many thanks, Veronica. So this is a very useful introduction, not only in generic terms, but also more specifically for cobalt. I think we are reassured to hear that cobalt in batteries will indeed be seen as essential. However, I think at the Cobalt Institute, we're just wondering whether the essential use, as you said, is a very complex framework set of criteria that needs to be developed. So whether this is really the best way forward in progressing in the avenue of future chemicals management systems. We have heard that cobalt has moved from candidate listing to authorization to restriction, and very good news for us now. You're confirming that this will be an OEL, binding OEL avenue, and we can only congratulate as the Cobalt Institute this way forward, because we think that the issue with cobalt exposure is a workplace specific one, and that's how I think the best regulation can operate at the workplace. So many thanks for this introduction again. I would now like to give the opportunity to our panelists to introduce themselves and their affiliation. I think they will be providing initial views regarding chemicals management and the production of cobalt-based battery technologies from their different angles. Let's start with Ms. Tulia Svaneva. She's a compliance manager for a Swedish company called Northvolt. Tulia, over you.
Thank you. So thank you for inviting me. It's so fun to have possibility to discuss with all of you, so knowledgeable panelists, after all these isolated months at home. So this is great fun. Thank you. So I would like to tell you a bit about the chemicals management work at Northvolt. Because the type of company as Northvolt is, I think the work is kind of a bit, it's quite special. The company is new, it's fast growing, and it's ambitious. So for the ones who don't know Northvolt, so Northvolt is an innovative European lithium battery ion company who has a mission to produce the greenest battery with the minimum CO2 footprint. And Northvolt is not only manufacturing battery cells, packs, modules, and battery systems, but also the cathode active material containing cobalt, lithium, manganese, and nickel oxide. And on top of that, Northvolt is also recycling batteries. And the goal is to have 50% of recycled materials in the battery cells by 2030. We are in 4 countries and have at least 7 locations, mostly in Sweden. So the challenge this brings to chemicals management is that we have both engineering, we have assembly, but also chemical production under one roof. This is, of course, not something unique. This is something that many companies have, that kind of challenge. But what makes Northvolt unique is going from a pilot scale production to a very large scale production by constructing a gigafactory and giga recycling factory in northern Sweden, being operational already at the end of this year and next year. And that's really what makes Northvolt so unique. That's the extremely short timelines. So within just 5 years, while growing from a handful of passionate individuals, we've been growing to around 1,500 passionate employees from around 80 countries. And that's amazing. That's unique. It grows very fast. And you can imagine the enthusiastic atmosphere when you have lots of new people entering the company every week. So, but it also has a challenge. You need to do training, actually a lot of training for all these newcomers. Another challenge is to build up all the ways of working. And what's really worked well when you had 20, 30, 50 people working in the same office who could easily talk to each other, it doesn't work when you have 1,500 people working from several countries, several locations, working with several different types of projects, product development, process development, designing and constructing new facilities. So what we have needed to do during this very short time is to actually build up structures and ways of working, which are for a big multinational company. That's not always easy when the company is still small. But what does this type of extremely fast-growing and ambitious company need to succeed? Well, that's predictability. But also transparency from the regulator side to be able to know what's coming. So regulatory changes coming up on a short notice or with a very short implementation time, that can be a huge problem because the design of a factory and ordering equipment, that's done years before the actual start of production. And the design is, of course, made according to current valid rules. And if the rules change in between, it could mean that your new facility is outdated on the start of production. And to avoid that, it's important, of course, to know what's coming, to keep updated, but also to have an opportunity to give input to regulatory processes. And also the impact assessment. That's important that the battery industry is taken into account, which of course it is in many cases. And so what I really want to say with all this, telling all these things, is that when building up a new industry, there is a lot of focus in the internal work on building up the structures, making sure everything works and you are compliant with all these millions of rules that we have. It's really tricky to keep focus on everything that's happening externally. So especially like right now, it's so many new different things coming at the same time. So me personally, I haven't really had the possibility to keep myself updated in the same way as I used to in different type of company where the how would I say, the pace is not as fast. So in the meanwhile, while waiting for what the chemical strategy for sustainability will bring, we'll continue recruiting talent, growing enormously, and designing and building new facilities. And of course, contributing to the objective of EU or carbon neutrality by 2050. So that was my introduction, just giving you an idea on how it is to work in a company like ours. But I really look forward to our panel discussion and to hear what the other panelists have to tell. Thanks.
Many thanks, Tulia. I think indeed we are all very concerned about the pace at which regulations come up, evolve, adjust over time. And this must be even a bigger challenge for a company who has its internal pace, which is very speedy. I understand that sometimes regulations move along months, and you're just indicated that investments are year-based decisions and not something you can change in a couple of months. So I think that's a very good learning lesson in your specific situation. Many thanks for that. After hearing about this EU-focused experience of you of Northvolt, Tulia, allow me to invite Ms. Anne Hagenaars, Global Manager Chemicals Compliance of multinational company like Umicore. Please.
Thank you for the kind introduction, Caroline. Well, as said by my colleague Jan in the previous session, Umicore is a global materials technology and recycling group. So we're active in different parts of the battery value chain, going from refining, the manufacture of cathode material, and also recycling. And we're very strongly committed to contribute to a sustainable future. And of course, it goes without saying that responsible sourcing is a key to our sustainability framework, but also chemicals management is an important part of our sustainability structure. And therefore, I'm thankful the Cobalt Institute is very active in this area and that we have a session today really dedicated on chemicals management. I would like to start with echoing what Tulia said on the need for predictability. It's also needed for a multinational or a global company. The chemical industry is currently looked at to deliver these solutions for climate neutrality and circular economy. And it's clear from yesterday and today's sessions that batteries are at the center of these goals, and it's a very fast growing market. So it's really, as Tulia also said, it's today that the industry is taking decisions on where to make investments for the next 20 to 30 years period. So for this, companies need predictability and certainty on what is at the horizon, also for chemicals regulations. An aspect I want to bring today, and that's also important for industry, is the need for global alignment of chemicals regulations. Today, regulations are being set separately per jurisdiction, while it's important to keep in mind that the battery value chain crosses the border of these different jurisdictions. So when developing new chemical regulations or when restricting a certain use, this can result in undesired trade barriers and also disruption of the level playing field. And this should therefore be taken into account when setting new regulations and during the regulatory scrutiny of a certain chemical. And also the potential impact on the entire battery value chain should be looked at, from sourcing and refining till the recycling of end-of-life batteries. And actually, all these regulations globally, they have one common goal, and that's the protection of human health and the environment. So it should be feasible to have more coherence between regulations and to look at this from a more global perspective. I will give a few examples. The first one is the UN GHS system. GHS stands for Globally Harmonized System for Classification and Labeling of Chemicals. So with the development of that system, the goal was really to have a global harmonization of hazard classifications. Now, a few years later, we see that jurisdictions start to implement their own hazard review. And as a result, global harmonization of classification is getting lost, and the original GHS goal as well. So for companies, certainly for global companies, this really complicates logistics and global trade. And it also results in a distorted competition, for example, when there's a more stringent classification in a certain area. And my question today here really is, why are these kinds of hazard discussions not held at the level of the United Nations? And with this question, I want to come to the announced upcoming reformation of the EU CLP regulation, where new endpoints and new types of classification will be brought up. And during this reformation, it will be very important to consider the global aspect as well. And the discussion should take place at the UN level first to harmonize these classifications on a global scale. If not, global trade will become more and more difficult. Another example I want to bring is the WTO, or the World Trade Organization consultation. This normally comes at the final step during an EU harmonized classification process for chemicals, and it's currently more seen as a matter of formality, while this actually should be a key aspect to avoid trade barriers and to keep the level playing field. So the reformation of processes under REACH and under CLP that are currently ongoing, they offer actually an opportunity now to also reform the involvement of the WTO, to address the global challenges we face and to keep the right balance in the level playing field. And the last example I want to give are the occupational exposure limits. The industry certainly agrees that the use of chemicals should be safe for human health and the environment. This is also certainly a key value for Umicore as well. But we should be careful to not set limits that are over precautionary and that go beyond what is required to be safe and that have no benefit to human health. Otherwise, it will really be difficult or even impossible from an economic and perhaps even a technical perspective to have a battery value chain in those jurisdictions that set too stringent values. It will not be possible anymore to compete with other regions, and the battery industry will be regulated out of existence in this area. And one of the consequences might be that, for example, finished goods will be imported instead from perhaps regions that do not have sufficient protection to human health. And also it will result in more transportation. This will bring additional CO2 as well as economic losses. So it's therefore really important that exposure limits are set in a balanced way, taking into account economic, but also the health and environmental impact it may have on a global scale. And with this, I will wrap up and stress again the need for a predictable regulatory framework, as well as the need to take into account in that framework the global dimensions of chemicals legislations, since these are both key for the battery value chain. And thank you, and I give the floor back to you, Caroline.
Many thanks, Anne. So we definitely hear your call for predictability, like Tulia had said, but also certainty and coherence. I very much like the three examples you gave. We will be actively contributing to the revision of the CLP. Hazard is the start of all chemicals management. So the idea of having one globalized hazard assessment at UN level would be a very efficient idea. Let's hope Veronica and her team can take that up. And in terms of WTO, indeed, we are too much seeing this as a last step formality, and it's actually a very essential step to take into consideration for a value chain like the batteries. And OELs, well, I think you said it all. So many things. Mr. Jonathan Buston, Principal Scientist at the UK HSE. Many thanks for having accepted to join this panel. We are actually curious to hear about your experience with the UK battery value chain and the complex management, chemicals management system that they are part of. Also, I would say in this times of peculiar times of post-Brexit situation. So UK is a bit sitting now in a mixture of chemicals management systems they have to respect. The floor is yours, Jonathan.
Thank you. So just a little bit for those of you who may not understand the UK system. So HSE is a workplace regulator of health and safety within the UK. What you may less well know is it actually has a science and research centre to back up some of what it does and to help with some investigations. And that's really where I sit. So I'm not there as an inspector, so I don't go around sites looking to see if they're compliant. I don't sit in policy, so I don't have an influence on what is the policy going out or actually a first line of sight on what policy is coming in. But I work as a scientist. So I joined 10 years ago. I trained as a chemist. So I've got and after training, I worked for over 10 years as a chemist. So I've got a good first-hand experience of dealing with all sorts of chemicals, not just battery-related chemicals or cobalt, but a big range of chemicals. When I joined HSE, I joined as a chemist looking at some chemical hazards. I also get involved in the assessment of major hazard sites. So those which in the EU legislation would be regulated under SFASO regulations. In the UK, we've called that COMA for some years. So I'm well aware of that. Now my role is primarily helping inspectors and helping policy people to understand what's going on in the world of batteries. I also run a research team that does quite a lot of practical work. Many of our experiments end up in fires of various sizes and excitement levels. But that's part of the understanding of what makes batteries safe and how they can be kept safe. So that's really my background. So I've been dealing for the last few years with a range of battery manufacturers, cell manufacturers, or users of batteries, to some extent recyclers of batteries. So I've got a reasonable understanding of what's going on in that world. Now, I guess a few more bits from what I'd like to say in the opening remarks. As a safety regulator, we're not just concerned with the hazards of a material. The material hazards are relatively well controlled so long as our material is controlled. So as an operator, we would always encourage folk to be well aware of the process hazards, not just the material hazards, because it's only when the process hazards go wrong that people are likely to get contaminated or hit by the material and suffer harm. So in all of our discussion today, we're talking about the material hazard, but let's not lose track of the process hazards that's going to create exposures. I guess the other thing to say in my observations is that the battery market is fast changing. Julia and Anne were talking about the changes coming through with Northvolt and other fast growing companies. We see that a lot in the UK as well as across the world. We're seeing companies looking to put in manufacturing gigafactories. We're looking to see recycling centres going in. We're looking at a lot of electric vehicle manufacturers wanting to electrify their fleet, having to electrify their fleet to fit with the net zero demands that are being placed on them. And so this field is rapidly moving. And I think coupled with those drivers as to what the field looks like, there's quite a lot of different thinking still about what the best batteries for the situation is going to be. Now, in the short term, the next 5 to 10 to 15 years, I'm pretty sure that will involve lithium-ion batteries of some flavour or other. But how much of that spectrum is going to involve the lithium-ion batteries that contain cobalt, as opposed to those that contain iron phosphate, that's less certain. And almost year by year, a pendulum swings from one line of thinking to another. So I think it is not clear quite what that long-term future is going to look like, nor even what the short-term needs are going to be in the next 5 years. we're aware of a lot of investment going on across Europe, looking at putting gigafactories to make cells, Northvolt being one of those, but a lot of the Far Eastern manufacturers are also locating over in EU. But quite what the format and battery chemistry that may become dominant if we have a single dominant form, that's less certain. I think it is clear that part of that equation is trying to reduce cost, because certainly the auto manufacturer world, cost is virtually everything, and anything that can reduce cost is a good thing, and that is in part driving the reduction of cobalt levels in batteries as they're being formed now. So there are performance barriers also to get over, because the battery is only useful if it's cheap, but if it does the job that it's intended for as well. So in terms of how the UK sits in this great field, as has been mentioned, with Brexit and the departure from the European Union, things are slightly different here nowadays. Now, I'm not the expert to talk about that, but in the short term, nothing much has changed in that the UK has taken the EU regulations and transposed those into national law. There are some quirks over the Northern Ireland, but I'm not going to get drawn into those at the moment. The way forward is less clear, but I think also the way forward is less clear for the battery industry in general. I think it is changing a lot. The demands on batteries are changing, and I'm not sure we've yet got to a static period of what the demand is going to be in terms of chemistry or format of cell. And quite where those manufacturing chains and the value chains lie, I think is still going to have a lot of development. I think that's all I need to say just at the moment. We can move on to the next panelist, but thank you for your time.
Many things, Jonathan. I think your intervention raises in particular, I think, the fact that it's really costs which drive a lot of changes in the battery value chain. It would be interesting to understand how chemicals management is seen as a cost in that value chain, of course. And what I like also is to hear that basically there's a lot of confusion whether you're in the EU, just recently out of the EU, or globally situated. There is ever-changing pace there that companies have to work with. So this is again adding to the need for predictability and certainty on the chemicals management aspects that we discussed before. Now for our last but not least panelist, Dr. Violaine Verhoogstraete, Chemicals Management Director of Eurometaux, of which Cobalt Institute is a very proud member. How is the metals sector tackling this ever-changing chemicals management world and make sure that at the same time the battery market remains competitive, because we know that many metals are used in batteries, not only cobalt. So what key trends should we collectively prepare for? The floor is yours.
Thank you, Caroline. And thanks a lot for the invitation. Very happy to see you all as we can today. Before really going to the trends, please allow me to share some thinking that we have at multimetallic Eurometaux level. Let me start by saying that we are really living in interesting times when it comes to chemicals regulation. As Veronica has mentioned at the start, the zero pollution ambition for a toxic-free environment is one of the building blocks of the Green Deal. And it's articulated with a number of unfolding strategies. We have heard about the chemical strategy for sustainability, but you also have the Zero Pollution Action Plan, the Industrial Emissions Review. And overall, this is really presented as an aid for the EU to decouple prosperity from harmful levels of pollution, while enhancing EU's resilience and strategic autonomy. And I think this is really important to keep in mind. So there is a lot to say about the chemical strategy for sustainability that has been issued in October as one of the first pillars of the zero pollution ambition. As Veronica has said, it's really targeting, of course, protection, but also to encourage innovation and the development of alternatives, but also to further increase the knowledge base and the control of chemicals. Again, things to keep in mind. So clearly, the CSS, as we call it in short, And there's a series of new concepts, substance of concerns, essential uses that have not been totally defined yet. We heard about it. It includes reviews of existing pieces of legislations like REACH and CLP, and it links, of course, with other objectives of the Green Deal. Now, on top of that, it has now been complemented by the Zero Pollution Action Plan that has the ambition to be a kind of compass to include pollution prevention in a series of EU policies. And then you have the review of the Industrial Emissions Directive that's ongoing, and that again links back to what we call exposure and emissions, aspects that are also highlighted in the CSS and the Zero Pollution Action Plan. But then on top of that, you have work ongoing in the other Green Deal blocks, as well on sustainable finance. And the latter is directly challenging the improvements that we want to make as a society to reach that better protection ambition. And all of this is happening at high speed. So overall, the regulatory picture is becoming very complex and challenging. I heard the needs for predictability and transparency. But what we see today is really something that's moving, still evolving a lot, and sometimes unclear in terms of impacts and potential solutions. And I have the feeling today that we are a bit lost. So please allow me to explain. We know, we feel that there are links between different pieces of the puzzle, but also that we won't be able as a sector to match them all, meaning that there will be trade-offs and difficult decisions to take. What concerns us today as Eurometaux, and that for us requires really urgent work, are the reactions that we now see versus this increasingly complex picture, both at industry and regulatory levels. You all know that feeling when you find yourself in front of a large, multifaceted obstacle. You're tempted to look at it facet by facet, piece by piece, to make the objectives and the work more bearable. However, there is a real risk now that we end by focusing too much on the pieces of the puzzle rather than on the puzzle as a whole, racking our brains and energy on details of terminology to really understand some definitions rather than keeping the overall picture in mind. But we also see sometimes a tendency to oversimplify by focusing, for example, only on the hazard of the substance, to prioritize, to prevent, to remediate, rather than on exposure, emissions, and risk that are more difficult to describe and to address. In our sector, we have hazardous substances. This is true for batteries as well, and therefore toxic-free is an impossible task in our view. Metals are needed, and consequently, we are calling now regularly to achieve coherence between the different objectives and the blocks of the Green Deal. We are really shouting for having balance brought in chemicals management because of climate transition goals, etc. However, we have not yet grasped how we can ensure that coherence and strike that balance. We have to keep in mind that the zero pollution ambition is a vision. It will take us towards, force us to strive for something that's toxic-free or at least less toxic. The main question for us today is how will metals, their uses in batteries, their hazardous properties fit in that picture in terms of knowledge, control, protection, and less toxic alternatives? What can we propose as a sector to reconcile an integrated sustainability without leading to polarization of debates inside industry or with other stakeholders? So I started by saying that these are interesting times, and just to conclude, because this is indeed the case, because of course there are opportunities, there are possibilities to create, to be innovative in the solutions that are proposed, but this will require our industry, companies and associations to be mobilized and to really dare to embrace the complexity, to articulate a communication on the impacts and on the way forward. So to start with, Caroline.
Many thanks, Violaine. I think it's very important notes you make there. First of all, being clear that non-toxic environment and batteries are simply not possible. I think we need batteries, we need hazardous substances, and then the ambition of a non-toxic environment can only be indeed an ambition and a vision. And I think we can summarize a bit your concerns about the ongoing changes to the chemicals management system as, perfect is the enemy of the good, or kind of good is perfect enough. How much more do we need to change our system to actually make it better, and at the same time make it simply impossible to implement and having to face trade-offs? And that makes me think a bit about the etymological origin of the word sophisticated, with sophist meaning fake or non-transparent. And that's exactly what we're coming back with the interventions made before. The more complex you make a system, the more sophisticated and targeting extra details in the CSS, for example, the less transparent it may appear and the more difficult it may be to implement that. So many thanks to all of you for extremely interesting kicking views, I would say. I would actually now ask you to address a number of questions we have received from the audience, amongst others. One of them, the first one I would like to ask is mainly for Tulia and Anne. We have heard about a number of things over these 2 days of conference, the availability of cobalt, the responsible sourcing, chemicals management, the maze that Veronica, Jonathan and Violaine touched upon a bit. How would you rank this in terms of resources deployed by a company to tackle these challenges? How high are they a priority? And in terms of chemicals management in particular, what are the pieces of regulation that give you the most struggle, I would say? Maybe Anne first, so we change the order a bit.
Okay. Thank you, Caroline. I think chemical management, it's really key. It's a license to operate for a company. So indeed, the company needs resources to tackle that. Today, we have focused a lot on the European legislation part. And for this alone, the complexity, the new topics that are upcoming, it requires resources to follow that up. But as a global company, you also have to overlook what's happening globally at different sites. And it becomes more and more complex, as I can say, because there are more reach-alike emerging legislations worldwide. And that requires also resources to follow that up, to ensure that we are compliant, that our production can continue, the transportation can continue. And that is really key, and it requires indeed a lot of resources and a lot of work from our side. Yeah.
Thank you. Tulia, your views for a company evolving such at a fast pace. Can you keep up with the chemicals management and the resources needed to stay alert, stay anticipating it, and so on?
Well, actually, I'm lucky enough that actually the fast growing has been including chemicals management. So that's also growing the resources we have for that work. Okay. But it's really a challenge, and that's also actually something that's not so easy to make everybody else in a company to understand that, it's not just REACH, it's not just ROS, it's a lot of different things. And it's a lot of internal training as well to try to understand, to explain what are all the issues and then handle all of them. And like for us, as we do also the battery cells, and not just battery cells, but also complex battery systems, it means that we also need to care about the components we're purchasing and having all those restrictions as well, and keeping track of substances in components. Yeah. And of course, when you sell your product in the market, you need to know about those market requirements as well. Exactly. So it becomes extremely difficult to keep track of. And that is actually one reason why I'm like really allergic to the idea of having more chemicals related restrictions or other things in new pieces of legislation, or putting things in wrong places. Because even in the situation we have today, it's difficult enough to keep track of everything. So, for example, the OELs you mentioned, Anne, of course, the levels of those impact us as well, but also where you actually put them. So the people who work with occupational exposure, so that they actually know what are the valid limits, to put all of them in occupational legislation and not kind of add those in REACH restrictions like we have for NMP, for example. But yeah.
That makes me think of a follow-up question for you, Tulia, would be, you need indeed to keep track of everything going on. You have this ambition of being a green producer of a green product. How do you cope, or how do you manage to actually keep up to date with everything happening in the value chain? Also, for example, at raw material sourcing point of view, how does that balance out with the attention you have to put on chemicals management compliance aspects?
I don't know if you can compare those. It's a lot of effort to put on raw material sourcing. It's definitely a very important part of the whole concept of Northvolt. If you wouldn't put a lot of focus on it, you wouldn't be doing what you wanted to do as a company. So of course there is lots of focus, but I don't think you can compare them. It's a bit like you said, Anna. It's just something you just have to do it, and then you have the resources you need to be able to comply. It's not like you have a choice.
Yeah. So the tough decision making that Violaine was referring to, the trade-offs that we have to prepare for. In a case of a company, you cannot afford that. You have to keep all your priorities under vigilance. Yeah.
Yeah, okay. Yeah. There are several things you have to do, and you just have to do them. You have no choice.
Yeah. Jonathan, I was wondering, in your experience working with the UK battery producers and users, have you been confronted with one specific legislation or one specific regulatory measure that is completely incomprehensible, and that maybe the UK value chain is trying not to have repeated in the UK regulation, for example, that really makes their lives, the production of batteries in the UK, more complicated than beneficial?
I don't think this is really a UK thing as opposed to an EU thing.
Okay.
I think there's hardness when you're coming to understand how a battery manufacturing plant, and whether we're talking about a cell manufacturing plant or a battery pack manufacturing plant or something that does both, fits into some of the existing legislation. And you'll typically get folk who are coming from other fields who are not used to handling chemicals or working with chemical compliance, who are having to deal with this as a sideline to their main business, which is trying to make cars or trying to make batteries for cars. So I don't think there's anything particular about the UK position. I think I've seen nothing different in the last 5 months as to what I've seen for the last 5 years. I think it's just trying to navigate a set of legislation that is unfamiliar to those who are majoring in making cars. I think that's probably the biggest comment I'd like to make.
Thank you, Jonathan. So nothing to put away from the EU legislation heritage so far, but it's a general situation of legislation in general that is difficult to follow and understand. Thanks a lot for that. Regarding the timing of all these processes, Veronica, Violaine, we now are experiencing more than 10 years of regulatory scrutiny on cobalt substances, cobalt salts in the candidate list. Possibly authorization didn't happen, a restriction, and then OELs, which will also take a couple of years to develop. How can you explain, or how can you match that with the need for predictability and certainty that the companies raised before that? Is that compatible, and can we actually improve that situation a bit so that we're not dragging industry for 15 years of uncertainty before they actually know what to do, and that they can match that with their investments? Veronica.
Yes, thank you. Well, yes, predictability and certainty and coherence are the key words, and obviously this is also what we would like. The issue is that with cobalt in the past 10 years, it took so much years because every discussion is very, very complex, and we have to consider a lot of aspects. And well, the aim is that with the whole reformation of the chemical strategy, I can only talk about the chemical strategy, but obviously there are also, as Violaine was mentioning, there are so much more going on. The aim is certainly to rationalize and to looking for simplification and consolidation. So this is the goal, and yeah, it's not an easy exercise. I think for cobalt, yes, it's true that even if it's now addressed in OSH, it will take time. That's also true. I think in more of a general and little bit going back to the previous topic again about predictability and certainty. For example, for the restrictions, what we would like is to go faster with the restrictions, and that's why, for example, grouping or having bigger restrictions to avoid regrettable substitution, for example, is a very key goal for us. And of course, if there are too many restrictions, then we have to also find ways for their derogations, but also derogation requires some time. So it's very, very complex. But certainly the aim is to find the best way. And now with this inception impact assessment and the whole process, we are really very much looking for also input from everywhere. But yeah, it's very difficult to address, definitely.
Thank you. Violaine, do you think that the example we have with Cobalt, who has basically been on a journey through a number of chemicals management pieces, and like Tulia was saying, there's not just REACH and ROS, there's so many regulatory pieces that you can be in, especially for substances like cobalt. Do you think that this would be something we could use in helping the Commission go through the CSS discussions, through all the consultation, the studies that are going on, and take also, even if cobalt has been mentioned as an example of a use in batteries that would deem to be essential in the context of a generic restriction, but subject to derogation, could we also alert maybe the value chain and the authorities about the stigmatization effect you have until you get this derogation because you're essential? How would you use the cobalt example to maybe illustrate some of the metal concerns we are confronted with?
Yeah, good question. Indeed, I think the inception impact assessment allows us now, certainly on REACH, CLP is another story, but certainly on REACH to further reflect about how on risk management, because at the end of the day, this is about risk management. The journey of cobalt along all those pieces was about controlling risk in the best way. It has been a long journey, indeed, to have been learning lessons from cobalt, as we had also from cadmium, from other metals, from nickel. And I think that indeed, based on those learnings, we have two things to do. Helping Commission probably with some solutions to facilitate that simplification, that transparency, that predictability is one thing. But as important, I think, is the capacity building within industry. Taking the time to really explain what's happening. I realize that the agendas of everyone are full, but this is really important as well, that the companies, for example, remain informed, are keeping up with the new changes in reflections in those trade-offs and in those balances that we need to strike. So I would use it certainly also in those contexts of restrictions that can indeed may have a lot of impacts, not only on batteries, but also on other uses of cobalt, etc. To try really to have a package that explains basically what has been our experience, but also what are our proposed solutions to facilitate, again, predictability, transparency, which are really key values to make it work.
Okay. Tulia and Anne, as producers of batteries and battery technologies, you're very often confronted with stigmatization of raw materials. You have to manage that. I would say remove the fake news and make sure that myths are debunked and replaced by actual facts. In looking at the future of chemicals management, currently there's a lot of focus on hazard. There's a lot of focus on managing risk, but not all risks. How do you think aspects like circularity, green energy transition, and things like that should actually be used to balance out, I would say, the stigmatization that is resulting from the hazard focus? Tulia, I think you're being very polite.
I'm
Sorry.
Going for my mute button. Yeah, I think that the thinking of talking about essential use, it kind of has a point there, because it brings in that aspect of that something, even though it's hazardous, it's still needed and you can handle the risk. So I think in a way that brings in that risk aspect. Then of course you can have discussions whether essential use is really the concept and the way to go. But I think it really is that, because that's something we need to do every day anyway. We're handling the risk. This is also the work environment. This is kind of basics in everything. That you should identify your risks. You should handle your risk, and of course you should, yeah. and I think of course hazard plays a role in giving you an idea on what are the biggest risks and where you should put effort. But I think definitely the risk should get more focus compared to hazard in the chemicals world, because that's wherever I've worked in the past, it's always the same. It's not so that you can just substitute. Everybody wants to substitute the most hazardous substances, but it's really hard work. It's a lot of effort. It could be decades of research to try to do that. You might never succeed, but those efforts are actually taken. Yeah.
Anne, anything to add there?
Yeah, I can totally agree with what Tilla just said. I think the regulatory framework should really be risk-based, because, as I said before, in batteries there will ever be hazardous substances present there. So if you focus on hazards only, you will unfortunately ban part of your chemicals that are needed for green technologies. So risk-based is really key here. And as you speak about risk, is you look at hazard, you look at exposure. If you can manage and control the exposure part, then actually there is no risk. And that's an important aspect to keep in mind when setting the regulation. If you compare it then with the other topics we have to tackle as an industry, on, for example, responsible sourcing, I think there it's more the ethical aspects that play a role. It's a separate topic. I think we're talking about the link that there might be is, of course, that in sustainable sourcing, human health and protection of the environment are key concepts there. And of course, workers, regardless where they are situated in the world, should be sufficiently protected. And that is actually covered in the responsible sourcing framework.
As well, okay. So basically, in order to achieve sustainability and make sure that sustainability is truly integrated in any decision making, there is no other way but to I would say, move away from a hazard focus and involve a bit more of a risk dimension. And coming back to what Veronica was saying earlier, I know that there is this focus to avoiding regrettable substitution, but I think we're all convinced that doing hazard-based substitution research is never enough to achieve sustainable substitution. Coming back to what you said, Tulia, regarding the essential use, you said that indeed it could be a solution to destigmatize chemicals. It may also not be the right tool to use. Actually, I would like to come back to the point made earlier. According to Veronica, this would work more as a derogation, so again, coming at the end of a regulatory process. How do you think, Veronica, maybe that actually essential use can actually increase the stigmatization of chemicals which are not yet derogated as essential? And even when they are essential, they could be seen as these golden chemicals that are very complex, very burdensome to address, with a lot of responsibilities, obligations, whatever. Has the Commission thought about the possible side effects of such an essential concept, more than just, if you're essential, you should not be bothered anymore?
Well, I think this is exactly what is currently being assessed. So it's just a viewpoint from which angle we are looking at. So if we say that everything that is very hazardous and not essential should be banned, but then then we introduce derogations so everything that is hazardous should be banned, but there are essential things that should be allowed, and so there's a derogation. And how do we frame that? Whether how do we cover it? It's at the end. It's just from which angle we are looking at. The result will be the same.
But the Commission is exploring that, basically.
Yes, of course.
Okay.
Yes.
Okay. And Anne and Tulia, thinking about, again, your investment cycles and the time related to those, how would you see a concept like the essential use or something similar working in terms of a timeline? We know that battery technologies, as Jonathan said, is ever evolving. We don't know what will be down the road in 5, 20 years from now. So how would that match with things that are deemed essential, called essential, or even worse, not called essential today, but they may become essential in future? How would you see this working as companies with your investment cycles? The dynamic part of it, and maybe you want to start this time.
Okay, I will start. Well, the investment cycles, they run over 20, 30 years. It's not that we now made investments for only a few years. So that's why we really need this predictability. And the design of these facilities is really based, as Tulia also earlier said, on the values and the legislations we have to comply today. Of course, there will be risk management in place to cover exposure as much as possible where feasible. And I think it's important there that we take into account that we have to look now at what's coming at the future, not to really ban this
chemicals.
Yeah, to ensure that we do not regret that we ban any substances at this stage, because now the investments are made for the coming 20, 30 years. And the production facilities are really designed to use the materials that are on the market today, and of course with the view on the next 20 years, what's upcoming there.
Exactly. Tulia, if we injected a kind of a risk notion in the essentiality assessment, would that work better than moving away from saying hazard banned unless essential, but we would just screen things based on risk before getting to a need to derogate or not? Would that help?
I don't know. What I'm thinking about this essentiality is, I know it's so much open and it could maybe become a great tool, maybe not, maybe yes. But what I'm thinking is, if something is identified as essential, for how long? That's also part of predictability. Do I know that, okay, if it's kind of gets the stamp, you're essential, am I that for 10 years? Or is that for 5 years? Or what does it mean? Or could it be so that somebody comes after 5 years and says like, yes, we had this great secret project and we came up with this fantastic solution, and then the Commission would say, okay, you're not essential any longer. How soon can those kind of things happen?
Yep.
But also, as you said, Anne, maybe something which is not essential today, maybe it actually would be essential in the future. So somehow, because that's also, of course, everybody's making R&D efforts, and you can still test, and that's, I'm sure legislation will allow even in the future that you can test and do tests in whatever substances you want to. But if there is like no point of doing it, like what's the probability that I could get this substance I am doing research on actually approved or getting this essential use stamp in the future?
Yeah.
If it's easy, if it's difficult, is it even worth doing that research? It's difficult. I also see your point, Veronica, also in grouping and trying to make the process more effective, because in a way that's what everybody wants. But that brings also a problem. If you have a lot of things in the same group, how can I know is it really the same properties that this substance I have has? Does it really fit into this group? Yeah, it brings a lot of uncertainty actually when doing these group-wise.
Thank you.
And it's also more difficult with the risk in those cases.
Violaine, you mentioned as part of the CSS who will be confronted with a substances of concern concept as well. Don't you think this is again bringing the attention on a hazard-based approach? I mean, what is the point if to actually enlarge the scope of substances to be regulated on a hazard basis when we all seem to agree that risk is a very important point to keep in mind? How can we as Eurometaux members actually make that point through this substance of concern proposed concept?
Yeah, for me, it's the most concerning one at this moment from what I see happening in the regulations, because it's not only happening, of course, in the CSS, it's mentioned in the Circular Economy Action Plan, it's mentioned in the taxonomy context. So, I mean, this is really about, well, there at least they're talking about minimization of substances of concern, and this leaves a little bit more leeway about how to minimize. So, but again, it's the focus on hazard is there, and unfortunately for us in the metal sector, we have substances for which we cannot stick only to hazard, because otherwise it won't work. So we really need to be able to talk about especially when you could talk about consumer articles, for example, to consider what is actually the exposure of consumers, what are the contact types, have a more global perspective on what substances we really want to have in terms of functionality, essentiality. I mean, a number of societal demands actually for those substances of concern, and how we can tackle them at best. Because again, when the substance of concern definition came out, when we reviewed the impacts on the metal sector, what we had in our portfolio, 80% of the substances in our sector are substances of concern. So it's really something that's for us, that's an immense driver at Eurometaux level to really reflect about what can we propose as a way forward to minimize them in terms of risk again and in terms of exposure. There is a focus on hazard because of simplicity, because we want to be effective, but we need to find ways to implement it that are more basically related to the control of exposure and of risk.
Thank you. We're getting to the end of the panel, so I wanted to ask maybe an open question for all the panelists now. Can chemicals management actually help us develop a globally competitive battery value chain? And if so, how? What do we need to do as companies, as stakeholders of the value chain, as authorities, and also as the Cobalt Institute? Maybe Jonathan, I think I will start with men this time. Maybe you want to start.
And you seem to have a choice of one there. But I think it's tricky. I think within the battery world, it's not just cobalt's in the value chain. It's not just cobalt that's going to provide a substance of concern, whichever legal words you want to use that. Nickel compounds are in there. NMP as a solvent is used in the manufacture. All three of those things cause significant work for chemical compliance managers around the world. The battery world is trying to move to different chemistries. There is an outcome that you could foresee that would remove the problem of cobalt by removing the cobalt from the batteries. That may lead to less energy dense batteries. Then you come down to questions as to what is essential. Is it essential your phone should be the same size as it is now, or is there a trade-off to be made for a bigger phone with a less energy dense battery but that removes the cobalt? So I think a lot of the issues that we face here are actually wider than just chemical compliance issues. They will impact on the chemical compliance. I think that's probably all I need to say there.
Many thanks. So it's chemicals management and any value chain are basically close friends, no matter what you have in the value chain. Veronica, maybe we can have you. So how does chemical management actually help developing a globally competitive battery value chain in your view?
Well, I think, as it has been said, we are working on it, and I think that a key message is that really now the moment to also contribute to create the future. But yeah, so I completely hear and absolutely take good notes of everything that has been said today, not only in the global sphere, but also the previous topics. But this is still under discussion, and we are waiting for input from everyone.
Tulia, is chemicals management enabling a global competitive battery value chain?
Yeah, I don't know if the thing that I have in mind is the kind of things that you had in mind when asking the question. But what I'm thinking is one important point here is to actually bring in more knowledge on what is in your products, and that's also what legislation is actually suggesting now. Mm-hmm. That, for example, when we purchase components, we really want to know what is in them. And that kind of information is quite difficult to get in many cases. And that is part of chemicals management to me. And another thing, it's actually a bit of a comment to what Veronica said earlier about the substance of concern. What I'm thinking is that by adding a new concept, it adds on to our headache and the complexity. We already have like so many lists. And what I think every company in industry is trying to do is to simplify. So you're trying to do like your black lists, totally banned. You're trying to make your gray lists. Get rid of these if you can. You want to give like a simplified picture to your purchasers and to product developers and everybody, no, these rather not. And I mean, if you add some more lists, you just would like to know, okay, where should I categorize it? But it just adds on the complexity. It would be great to use some of the existing lists, which we already kind of placed in one of these categories. So that was what I was thinking about.
Thank you. Anne?
Okay. Well, I think the developments in battery technologies, they're not driven by chemicals legislation. They're more driven by the performance needs, or what we need as a society. It is, of course, the other way around. If there's a certain hurdle in chemicals legislation that would not allow us to further grow the battery value chain, that would be, of course, an important topic. But it's not the other way around. What I do think is that chemicals management and we as industry, also the Cobalt Institute, is collecting a lot of scientific data on and gaining a lot of knowledge on our materials, and that is of course important for the human health and environmental aspects. I think that robust data sets we have built over the many years, that's really key to use for our compliance globally, but also for our knowledge as a company how to deal with these kind of hazardous substances. And yeah, with that, I would like to end.
Thank you. Violaine, you will have the last words of this panel.
Well, thank you. Maybe not to repeat, but just to come back to a comment that Anne made at the start. Hazard doesn't change across the borders. So I think knowledge indeed is important. The questions that are posed everywhere in the world about handling chemicals are the same. So if in Europe we managed to find some solutions to those compromises, those coherence, predictability, together with all partners in chemicals management, I think it will make us quite competitive. And just to conclude, I think Jonathan raised the point of knowledge on materials, which is one. Knowledge on the process is the other one, especially in the batteries. I mean, it's quite important as well to remain explaining what's happening there, because we can also be quite competitive in communication overall. And the Cobalt Institute does that very well.
Many thanks. So I think to the question, can chemicals management actually allow a global competitive battery value chain? We can basically say yes, provided that it does not impede to meet the societal needs, which is what is driving the need for batteries. So with this conclusion, I would like to thank you very much, all of you, for the very interesting insights. We look forward to hear from you with the Cobalt Institute or beyond towards the rest of the day in the conference or anytime you wish. So thanks again. Now I'll leave you the floor. We'll give the floor back to the colleagues who will be introducing the benchmark workshop. Thanks a lot.
Good afternoon, everyone, and welcome back to the final session of the 2021 Cobalt Conference. I hope everyone has enjoyed the session organised by our colleagues from Benchmark. Certainly some very interesting discussions and debates there. For our penultimate speaker now, it's been a great pleasure to be able to introduce to you Professor Kristin Persson, who is Professor of Materials Science and Engineering at the University of California, Berkeley. Professor Persson is also in the faculty at the Lawrence Berkeley National Laboratory and Director of the Materials Project. As you can see, she's speaking to us today from sunny California, so we're all a little bit jealous, certainly in Europe where it's grey and miserable weather. But Professor Persson has kindly agreed to speak to us about sort of battery chemistries and really what's happening in that space. So really fascinating to hear the presentation. So Kristin, the floor is yours.
Thanks so much, Adam. It's my pleasure to be here. And I did grow up in Sweden and spent 28 years in Sweden. So I do know what you're talking about in terms of the grayness. So it's my pleasure to be here and to talk a little bit about the battery sort of chemistries and the roles they play and maybe where we're going. So batteries have become ubiquitous, especially in our portable electronics, and is now making an inroad into transportation as well as our grid applications, specifically to enable intermittent clean energy production from, for example, wind and solar. And we're projecting a growth in terms of demand of energy storage. If you look at the history of batteries, the first time anything was called a battery was in 1749 when Benjamin Franklin made what he called the Leyden jars. They were actually not what we would call batteries today. They were capacitors where you store the charge on the surface of a material rather than the bulk of the material. And the real first battery that we are aware of is a Volta's pile from 1800. That was in aqueous zinc copper battery. The first utility company that used batteries was under the directorship of Thomas Edison. Thomas Edison had just invented his light bulb and he was looking to light up Manhattan. And just like us today, he was dealing with unreliable intermittent supply of electricity. So he needed a buffer and he was very interested in using batteries for this. Unfortunately, the battery market at that time sorely disappointed him. He wrote a fairly fiery article in The Electrician, and I'll read verbatim. The storage battery is a mechanism for swindling the public by stock companies. It's one of those peculiar things which appeals to the imagination, and no more perfect thing could be desired by stock swindlers. Just as soon as man gets working on the secondary battery, and by that he meant rechargeable batteries, it brings out his latent capacity for lying. And this frustration of Edison's led to him inventing the iron nickel battery that then powered the first utility company at the Pearl Street station in Manhattan. So this isn't entirely, while maybe a bit temperamental, it's not entirely wrong today. I'm sure you've all seen the different kinds of announcements about different battery chemistries, and they're all going to be much better than what we currently have. There's a little bit of hype around what batteries can and cannot do, and it's also a bit of the skill in talking about what they're good at. There are different kinds of metrics, and I'll get to that. So, as I said, we actually still have Edison's problem today. We are also dealing with, maybe unreliable is not the right word, but we're dealing with intermittent energy resources that we would like to utilize more than we do today. In order to do that and to sustain our ability to use electricity reliably, we need that buffer, we need that energy storage. And that's where the energy storage sort of market comes in. If you look at different comparisons of energy storage, there's a variety of different solutions. Batteries is not the only one. If you look at capacitors, those are great for very fast and long lifetime applications, but they don't have a tremendously high energy density by volume because all the charge sit at the surface. And there are the hydrogen solution, the hydrogen economy, which relies on the production of a fuel, for example, hydrogen, the storage of that fuel, and the transportation of that fuel, and eventually the burning of that fuel in fuel cells. This is a potentially very clean and attractive solution, but the overall efficiency today, from production to storage to transportation and to burning it, needs improvement. Let's just put it that way. Batteries is today the most reliable and utilized energy storage of the new kind of energy storage outside of hydro, and it's really because of it's been commoditized. We know how well these batteries tend to work. It's the reliable, even for grid applications in the US. Over 90% of new grid application energy storage is lithium-ion batteries. That being said, in different parts of the world, you could be using something like pumped hydro. Compressed air has been popular for a while, flywheels. Some of these are geographically limited, especially if you're looking at pumped hydro. Compressed air and flywheels have dealt with issues like mechanical failure and response time. More exotic solutions like superconducting currents I just put up there because it's as scientists, we never start thinking about what could be the next thing, but that is really a bit out there. So if we're looking at batteries specifically as one of today's most promising ways of introducing more energy storage across the board in transportation and in grid applications, out of the battery chemistries that we're aware of, that we have available today, lithium-ion is by far the most utilized one. This is a bar graph that shows the evolution of the worldwide battery market from 1990 to 2017. And as you can see, it's completely dominated by lithium-ion. So how does a battery work? Which sort of informs what can we do to improve it? Where can we go from here? A battery really works by having two materials that want to react with each other. Here I call them A and B. A and B really wants to exchange a lithium atom, an electron and a lithium plus cation. And by separating those two charges, by allowing the lithium ion to go through the electrolyte and the electron has to go through the outer circuit, you're enabling the discharge of a battery. And that's the reaction that wants to happen when you put these materials in contact with each other and you allow that electron to flow. But of course, then you have to put that energy back into the battery to move the lithium ion and the electron back to where they really don't want to be. And that's where we put the energy into the battery. That's when we're charging it. And that's really converting the chemical energy, the electrochemical energy from the reaction that wants to happen that enables us to use that stored energy. If we look a little closer on what kind of materials are used in today's lithium-ion batteries, on the right-hand side, you have the cathode, which can be a number of different materials, and I'll get to that. But the most common one today is the layered family of materials, where you have the sandwich structure, where you have oxygens and transition metals sitting in a sandwich. And then it comes a layer with lithium and another sandwich layer of oxygen and transition metals. And because of that sandwich structure, you're allowing the lithium ions to move in and out of the material, and that's your charge and discharge mechanism. And similarly, on your anode side, on the left-hand side there, you typically have graphite. There's a little bit of blending in of silicon, but graphite is the main anode today, where again, you have the sandwich structures of graphene layers that are stacked up, becoming graphite. And you're, again, by charge and discharge, you're moving the lithium ions in and out. And then the electrolyte in between is where you're using an organic electrolyte today, because we need higher, this is quite the voltage difference between these two anodes, the anode and the cathode, basically the energy that they want to react with, and that has to be sustained by the electrolyte. Basically, it cannot break down under that voltage. So there are a number that matter for battery evaluations. And this is one of those ways that people can tell you about a battery chemistry, and they may not talk about all the different metrics that matter. We tend to use these spider charts to really talk about what are the different metrics, and how does the particular chemistry or the particular application respond to those different metrics. And there could be a diversity of solutions for different applications where some of these things matter less or more. So durability, for example, could be very important for grid applications where you don't really want to replace your battery every 2-5 years. Whereas in your portable electronics, maybe that's fine because you want to change your iPhone anyway or your laptop anyway between 2 to 5 years. Cost is, of course, an important factor, but it depends on what time scale you're amortizing that cost. Volume, the energy per volume is important in some cases. So for example, in portable electronics, the energy per volume, the volumetric energy density tends to be very important. So that speaks to a particular kind of chemistry of your battery. But for example, the energy per weight can matter for other things. So this is an important chart in the sense that if you're wondering, why does this particular chemistry get sold as the next best thing? It could be because they're not telling you about all the different metrics on this chart. I talked about Edison's battery. Edison's battery was the nickel iron battery. That was a water-based precipitation dissolution battery. And those tend to be much lower energy and also lower power than the ones we're using today with organic electrolytes and intercalation as the charge-discharge phenomena. So it sort of sets the scale where these different kinds of battery chemistries, where their technology actually influences how they perform. If we look a little closer at the cathode, we also find out that the cathode isn't exactly just one chunk of material. It's actually small particles that are then blended in with carbon too, and a polymer and a binder. And then that is actually flooded with the electrolyte. So I'll say something about how the architecture, this typical box picture that we have as batteries that I'm using too, isn't very illustrative how a lithium-ion battery actually looks like. So a lithium-ion battery, rather than the box picture, is actually long sheets of metal. So the current collectors are long sheets of metal, and you deposit upon that a slurry with the cathode particles and the little carbon particles and the binders, and you dry that out, and you put a separator in between, and then you do the same thing with the anode and another current collector, and then you flood the whole, and you roll that up into a jelly roll, and you flood the whole thing with electrolytes. So there isn't really a box of any kind. And this technology, the way that we make these batteries, informs not just the cost, but also its performance, its rate capabilities, and also may speak to the future of how do we do this when we do something like, for example, solid state batteries, which may not be amenable to the same kind of manufacturing. So talking a little bit more about the cathodes of today, the most used one is the layered cathodes, the one that I show on your left-hand side there, where you have different kinds of transition metals in the layer. Previously, in the sort of race for different kinds of materials, we have looked at things like the spinel structure. The spinel structure has lower energy density by volume, but it's quite safe. And if you go even further on the safety curve, you find a lithium iron phosphate, which is very safe, but also has quite a bit lower energy density per volume, something around the 50 to 60% of the layered cathodes. The energy density tends to correlate with safety. The higher energy density, the higher voltage you go, and the more charge you draw from your battery, from your material, tends to correlate negatively with safety. So lithium iron phosphate in the axis of safety, it has the lowest energy density of all the different families of cathode blends and cathode structures that we've been looking at. But it also is the safest, but also the lowest energy density. If you go on the other direction, you find lithium nickel oxide, which is completely the layered material again, but has only nickel in the layers, which is one of the most unsafe batteries. But again, A lot of the safety today is engineered on the cell level, but it is an important consideration. So the original layered cathode, now moving from the families of different cathodes, here's the layered one that is the dominating one today in today's market. Started out with John Goodenough's discovery in the 70s, for which he got the Nobel Prize. The lithium cobalt oxide is the original layered material. We only operated on about 60, 70% of its theoretical capacity, because if you charge it higher, it becomes unsafe, as well as you lose rate capability. The lithium ions can't go as fast between the layers anymore, because those layers have crunched in a bit because you removed a lot of the lithium ions. So it sort of gives you a sense of that this material could potentially even do better if we could engineer it, but it's been tried. So lithium cobalt oxide is the parent of the family of NMCs. So the NMC family stands for nickel, manganese, and cobalt, where manganese is not used as a discharge material. It doesn't undergo redox. It is there as a stabilizer. Nickel and cobalt are both undergoing redox. And the way that the way that we denominate this is the 1-1-1 is where you have equal ratios of these three metals in the sandwich layer between the oxygens. And if you go to 8-1-1, you're now 80% nickel and 10% cobalt. And we have been moving towards the sort of higher nickel content for a number of years now. The workhorse in today's electric vehicles is the 622. As you charge and discharge the battery, as I said, you remove the lithium from between these sandwich layers in and out. It's a little bit like if you remove too much of this lithium, as I said before, it's a little bit like playing Jenga. Like some of these, especially the high nickel content materials, as you move above lithium, you get some destabilization of the structure, which correlates with oxygen release as well as structure transformation. So if you look at this is a graph that shows that as you go to higher nickel in the NMC series, so even going all the way up to lithium nickel oxide, 100% nickel, that correlates with thermal instability. That has to do with the fact that the structure in itself really doesn't want to stay. Nickel oxide, NiO2, is thermally unstable even at room temperature. It wants to release oxygen, it wants to transform into another structure. And that affects both the safety of the battery, but also the charge discharge. So this tends to happen at the surface of the particles where you lose the oxygen, you then move to another kind of structure, and which doesn't transport lithiums as well as the nice sandwich layered structure. And that's really where some of these issues come from, and we can't charge it all the way up. So we're losing some capacity that way. You might ask, why do we only make layered materials with cobalt, nickel, and manganese, especially considering some of the resource issues surrounding cobalt? There's actually a fundamental reason why the nickel and cobalt are the only transition metals that will reliably work in these kinds of structures, in these kinds of ordered structures. And I'll just walk you very briefly through the sort of fundamental reason for this. Otherwise, this could be like, well, why can't we use something else? Iron would be great, for example. So when you discharge and charge, if you were to try to put something else, let's say you were to try to put iron or chromium or vanadium or something else, what happens when you discharge and charge your material is that these transition metals, which I now denominate that has these purple or blue color in their polyhedra, they actually want to move into the lithium layer. So this is what would happen if you put something else in these layered materials. And the lithiums would now move into the transition metal layer, and you would end up with something that looks quite different than the layered, nice ordered structure you started with. And this tends to not only degrade the voltage of your material, but also the ability to move lithiums in and out, because you shut down basically paths. And this is really the reason that we get this movement of transition metal ions from the transition metal layer into the lithium layer depends on the electronic structure. And the electronic structure is where the electrons sit and what kind of orbitals they sit. And nickel and cobalt are the only ones where you, through the redox cycle going from 3 to 4, actually doesn't want to move into that layer. It prohibits it. Their electronic structure, the way that the electrons arrange in these materials, prohibit them from moving. So that is a fundamental reason and not something we can easily change. So nickel and cobalt are the two things we need. That of course begs the question, can we supply the future battery market with these two metals? And I know you've had a lot of discussions about this already. Depending on what projections you believe, is anything from a couple of terawatt hour by 2030 to, if you believe Elon Musk, who wants 20 terawatt hours by 2030. And that really translates into quite a lot of metal. So 10 terawatt hours translates into about 10 million tons, equivalent tons of metal, either nickel or cobalt or a blend of both. So 10 million tons. If you look at the cobalt production today, the total cobalt production is about 150,000 tons. And there are different estimates of where we're going with this. This is one estimate out of an academic group. There are other differing opinions about this. So let's focus only on today's estimate, or today's production. It's about 150,000 tons. That's a factor of 100 away where we need to be if we're going to supply this whole projected market by 2030 with cobalt. So let's look at nickel. Nickel is a little bit better. Today's nickel production is 2.4 million tons, but a lot of that goes to steel production. And it's not really, we can't take it all for, which is the same as cobalt. There's many different demands for cobalt, and the same is true for nickel. It's unlikely we'll be able to take all this nickel production and turn that into batteries. So there really is a tremendous demand, and this is where the research community has been looking. We've gone to higher nickel content to try to mitigate the resource limitations on cobalt. So we're now looking at the 811 series, but we're also looking at non-nickel, non-cobalt containing cathode materials. There's one interesting family, what we call the disordered rock salts, which instead of having these nicely layered structures actually allows for disorder, which means that it's okay for the transition metals to move around and still keep the voltage and still keep the lithium percolation paths through the material as we charge and discharge the material. These materials are being researched today in the lab, so they're not commercially available yet, but they are a potential avenue forward to supply a large demand of maybe different kinds of varieties of batteries. And this is just an example of how these different DRX materials, disordered rock salts, can actually just work quite well with a diversity and a variety of metal cations. So I think I'm out of time, and I'm just going to end with my outlook here that the nickel and the cobalt dominated lithium-ion batteries are going to be, in my opinion, the workhorse for energy storage for the next foreseeable future, definitely the next 5 years. You don't see anything going into the commercial sector until it's made its entry into portable electronics or military applications. In terms of energy density, lithium cobalt oxide is incredibly hard to beat. It is the most energy dense by volume cathode that we have, and it's always going to be the preferred choice for things like portable electronics. Transportation is, in my opinion, the largest coming market. And there we might see a diversity of cathodes, depending on where the prices and the resource limitations get us and the research for new materials. And I'm really happy to be here, and I'll be happy to take questions if that's part of the forum.
Kristen, thank you so much. I think we do this format, we don't necessarily have capacity for questions, but I think it was a really interesting explanation and journey through battery technology when Edison was first making statements like that. It shows, I guess, in what a relatively short space of time how far we have come. And as we look to the next generation of batteries and also the battery mix, I think the discussions we've had over the last 2 days have really shown that it's not going to be one technology doing everything. There will be various different chemistries available, and obviously the role that cobalt plays will still be important and we believe critical in that. And of course, looking at where we get future supply from, we did have discussions yesterday on this, and that is an area that the industry still needs to focus on the work. I think it's really interesting to hear from a sort of the research perspective as well, what those considerations mean onto the research agenda as well. It remains with me as a sort of last part of our conference today to first of all thank Professor Persson for her introduction and welcome Dr. Michael McKittrick to the conference. Dr. McKittrick is currently serving as the acting director of the Advanced Manufacturing Office within the Office of Energy Efficiency and Renewable Energy at the US Department of Energy. He's also leading the R&D consortia, which brings together the office's public-private research consortia, which is working with manufacturers, small businesses, universities, and the national laboratories to look at R&D into sort of high-priority energy research. Dr. McKittrick has been active around sort of critical materials, as responsible for writing the department or being a co-author of the Department of Energy's critical materials strategy back in 2011, and has worked on rare earths and other critical materials and their application into energy technologies, and holds his PhD in chemical engineering from Georgia Tech. So, Dr. McKittrick, welcome. We've had an interesting couple of days. Really looking forward to sort of hearing your perspectives. And I don't know if the floor is yours, but certainly the screen is yours.
Excellent. Thank you. I appreciate the welcome and appreciate the opportunity to come and speak with the group today. As you mentioned, it's cobalt and critical materials have been something that I've worked on, and the Department of Energy and even the advanced manufacturing has worked on for about a decade, and happy to come share a little bit of what we're doing. So I'll jump right in, and just to give a little context, I'll provide a little background on my office, the Advanced Manufacturing Office, and why we care about things like cobalt, and then provide an example or two of some of the work we're doing, critical materials and cobalt, to help inspire maybe perhaps how the participants here can work with the U.S. Department of Energy moving forward. So again, I sit in the Advanced Manufacturing Office, which is part of the department, and really, we're really looking at how to address the climate crisis. If you take a step back in terms of the U.S. Industrial sector, it accounts for about a third of the U.S. energy use, and that translates to about 28% of the carbon dioxide emissions. And we're thinking about not only the manufacturing sector, the agriculture, mining, construction sectors as well. So that's a huge challenge we need to address, and then consider the potential growth of those sectors is kind of globally. Globally we're expecting increases in all these sectors. And by 2050, there's projection that may result in another 15% in CO2 emissions. So we need to act, and we need to act now on this. And so really what my office has done is we work with, we fund research and development, demonstration and deployment with companies, universities, DOE national labs, to develop the technologies and get them out to address these key issues. And thinking about the supply chains we need to address these materials. So things like wide bandgap semiconductors, or advanced composites, or high capacity batteries for energy storage. We're thinking about an industrial decarbonization roadmap, and energy storage is a key piece of that. And how do we achieve the Biden administration goals of net zero greenhouse gas emissions by 2050? And as a whole, my office looks at energy intensive industrial processes. So how do we actually move on from some of the more polluting, energy intensive manufacturing materials and unit operations, so we can move forward to drop the emissions from these sectors. So just to give you a little flavor of how we tackle these problems, is we really think about our work in a couple of key areas. Is materials, is what are the new materials we need for energy applications, and how do we strengthen supply chains like cobalt, and we'll dive into that in a little more here shortly. But things like also, how do we recycle more materials, both plastics, metals, fibers, electronic waste? How do we drive the manufacturing innovations, things like additive manufacturing, automation and controls? And as we're adding those, how do we make sure our manufacturers are cyber secure? And then really applicable to this meeting is energy systems. So not only things like combined heat and power, but grid scale storage, as well as mobile storage. And then ultimately, as we're thinking about all these, and especially in things like cobalt or other critical materials, is the manufacturing enterprise is a key piece, education and workforce, making sure we have the not only training the students, but current workers to move into these new manufacturing supply chains. So that's kind of a little context for what my office does, and then so just a bit about the department's approach on critical materials and including cobalt. So as Professor Person just mentioned, there's a key need for many materials, especially for things like lithium-ion batteries, and the department is really looking at that as we're thinking about our approaches for decarbonization. So how do we drive more wind, solar, other renewable technologies onto the grid? So we need rare earth elements for electric vehicle motors, offshore wind generators, lithium-ion batteries, we talk about transportation, other mobile storage, catalysts and fuel cells for things like hydrogen utilization, solar, lightweighting alloys, and energy efficient lighting. And so there's a huge demand for these materials now, and there's strained supply chains, as you all know. And the problem is only going to get more challenging, especially if we're pushing towards these goals of clean energy, completely clean energy grid by 2035, or decarbonizing the industrial sector by 2050. The demand growth for these technologies is only going to increase. As mentioned, and there are things like cobalt, lithium, as we heard, nickel, manganese, graphite, rare earths, especially like neodymium and dysprosium, are going to be critical as we think about this transition to a carbon neutral energy future. And while for some of these materials, the clean energy applications are not the major driving demand. So I think about what for cobalt is about half of the demand is for batteries at this time. Some projections expect that the mineral demand for these clean energy technologies is going to rise by at least 4 times. So again, we already have strained supply chains, and the challenge is only going to get worse. So then, just framing back a bit from the Department of Energy perspective, and especially from my office and the advanced manufacturing, how we think about the problem a bit, is that in the U.S. So we have a quite a large number of potential resources for critical materials, including cobalt. And this map is a map from my colleagues at the United States Geological Survey, USGS, and kind of highlight some of the key critical materials there. But then on the table on the left, you can see the U.S. import reliance. So despite kind of this potential mineral wealth, the U.S. is still reliant on other supply chains for these materials. And really the crux of the problem is it's not just a mining problem or an extraction problem. It's a processing, separation, downstream manufacturing. And if we don't tackle the entire supply chain, we're really just shifting the risk around. And that's a lot of work that my office has done. So I apologize for the phone in the background. And so really what we're thinking about in the Department of Energy is how we can pursue secure, resilient supply chains across these product life cycles. So not only think about the resource extraction, but also the manufacturing in the middle, as well as the recycling and reuse at the end of life. Because a key component, especially for things like cobalt. How do we target place-based solutions and demonstrations that can drive job growth as well as develop the clean energy technologies? And in the department, Professor Person talked about a little bit about the research going on that is going on in the area. In the Department of Energy, we really try and fund research across the entire innovation pipeline, from fundamental science, developing new materials, to manufacturing scale-up. So within DOE, we've been working in critical materials for a number of years. As mentioned, we wrote a number of critical material strategies in 2010 and 2011, and have really built a large R&D portfolio off of that. And the R&D is really organized in a couple key areas: is diversify supply. How do we drive new sources, develop new sources from things like mine waste, lean sources? How do we improve the extraction, separation, and processing? And develop new uses for co-products that come along with some of these critical materials and minerals like cobalt. How do we develop substitutes? So not only things, element for element substitution, but how do we think about system substitutions or components of substitutions? Can we develop flow batteries that may serve as a good replacement for potential lithium-ion batteries for grid scale storage or stationary storage? And then how do we improve recycling and reuse? I think as a whole, it's a pretty low recycling rate for most critical materials, things like cobalt, rare earths, lithium. How do we actually improve collection and develop technologies to remove those critical materials and reuse them? So can we use additive manufacturing to make new magnets from recovered magnets, for example? So we're doing a lot of systems analysis as well, and are really kicking off some of the demonstration efforts in this area, actually getting things from early stage technology development more closer to industry adoption. And then just across the department, we've engaged in this, our Office of Science has a number of large user facilities that have world-class scientific capabilities as we're looking at this. As we talked about, we've done a number of criticality assessments looking at the potential demand growth for clean energy technologies, as well as the supply of critical materials and where are the potential pain points there. We work across not only the federal government, we also work with international colleagues. We've had a long-standing trilateral engagement with the European Union and Japan on a number of topics, and really talk about the technology development areas where we can collaborate. We also have bilateral agreements with Canada and Australia in the area. And then within the US government, there's a lot of collaboration. There's an interagency committee of the key federal agencies. I think it's the Department of Defense, Department of Commerce, EPA, where we collaborate on these topics. So just to dig in a little bit more, to give you a little flavor of some of the things we're doing in my office as well as the broader office. So the ERE is the Office of Energy Efficiency and Renewable Energy. It's kind of the office that my office AMO sits under. And we have a couple of offices that work, or groups that are working in critical materials. I'll get into these top two on the Critical Materials Institute and some of our work there in a minute. But I do want to highlight, we have a vehicle technology office, and they've done a lot of sponsored a lot of research and development, thinking about low or no cobalt cathode R&D. So really looking at how you can drive that down a little bit, similar to the discussions that Professor Person just went through. They have a goal of reducing the cobalt by 90% in some of the new materials they're looking at. They also look at direct recycling and reuse of lithium-ion batteries. So how can you recover the cathode and anodes and actually immediately reuse them in new materials through a partnership with Argonne. We also have some work in our geothermal office, more looking at lithium on the battery side, of how you can recover lithium with geothermal brines, and some collaborative efforts where we're thinking about how to improve the collection, storage, and transportation of discarded lithium-ion batteries, so we can enable that recycling of the materials within them. So I just want to highlight one of the efforts that my office has funded for about 8 years. It's called the Critical Materials Institute, and we call it an Energy Innovation Hub. And essentially, it's a large public-private partnership and looking at the technology development on how to improve the supply chain for these materials we're talking about, for EVs, wind generators, energy storage, solar, other electronics. So it's led by Ames Laboratory, which is one of our national labs, but has a host of other net labs, universities, and industrial partners. And they're really hitting the research in those key areas I talked about: how to improve supply, develop substitutes, and improve recycling and reuse. And that's really strengthened by the cross-cutting area, which, as we know that there's a lot of the fundamental science for some of these materials that we don't quite understand yet, and we need to continue that research to enable technology development. And CMI has been quite successful over their 8 years, not just a fundamental science organization, a number of invention disclosures, over 150 patent applications, and actually have 10 technologies that they've licensed to industry and that are pursuing follow-on fundings or technology maturation to be deployed. So just to give you a little more depth on CMI, again, it's a large organization. Across those members, we have about 250 people engaged, and it's about 35 organizations that are involved in that. And those are mapped into 35 different research projects. If you kind of see here, we call these the focus areas in CMI. So again, diversify supply, in developing substitutes, driving reuse and recycling, and cross-cutting research. And so they have a large team in each of these efforts, really looking to move not only the science, but the technology development forward. And one of the great things about the long-term investment in these areas, and so just for a little context, DOE has invested about $25 million into the Critical Materials Institute each year since 2013. And we expect it to be a 10-year lifetime. So that will be a total of a $250 million U.S. investment in this area, which is really the largest U.S. government R&D investment in critical materials. And through that investment, CMI has not only done a lot of great research, as they developed a lot of great capabilities to tackle the critical material problem. And it is a larger issue or larger material set than CMI is tackling than just cobalt. They're looking at rare earths and lithium, but they have developed a lot of capabilities. So, for example, one of the key bottlenecks in rare earth production is the separation. When we mine rare earths, we don't get just one material; we get all 15 rare earths, and we really want neodymium and other materials for magnets. And at Idaho National Lab, they have a great pilot system to actually separate the individual rare earths. Then how do we make metals? Not only for rare earths, but things like cobalt, or even we're thinking about lithium metal for potential new battery kind of configurations. Things like manufacturing. So as we're looking at a lot of these critical materials, especially as we're going through the processing, they're very air sensitive. CMI has a controlled atmospheric system to actually think about new magnets. So not only cobalt for battery applications, a lot of what CMI does is looking at cobalt in the magnets. So how can we develop new manufacturing technologies for samarium cobalt magnets, or actually strengthen those magnets? One of the challenges is they're extremely brittle, and for a lot of industrial applications are not compatible compared to neodymium iron boron magnets. So we're looking at how to improve those. Really across the supply chain, again, of various critical materials, CMI has capabilities where industry, academia can come in and catalyze the technology development. So shifting a bit, so again, we mentioned a bit that CMI has 35 active projects in the area. One of the things we worked with them on in the last year was to open that up to expand the palette, as we're calling it. Again, a lot of the focus in the early years were on rare earths and lithium, but similar to everyone here, the department recognizes the growing importance of cobalt and especially high-grade nickel and manganese for energy storage. So we're starting some new projects, and 3 of those are focused on cobalt. We'll highlight the first one is thinking about one of the key gaps for rare earths. Is again the metallization stage, actually taking the separated rare earths, make it into metal before you make it into the neodymium iron boron magnet. It's a key gap really in a large part of the world. So how do we develop better technologies for that? And then we have several projects looking at cobalt recovery. One is thinking about on the recycling and reuse. How do you drive better cobalt, lithium, and manganese extraction from lithium-ion battery cake? And then we have 2 projects where we're looking at how do you improve cobalt recovery from raw material sources. So one is in central Idaho. There's a deposit there and so the CMI is working with First Cobalt, as well as our lead academic partner, Colorado School of Mines. How can we improve the processing to economically, as well as making sure environmentally, sustainably extract that material to recover cobalt. And the other new project is we're working with Doe Run, as well as a university in Missouri to explore the deposit there. Again, and our efforts aren't on the extraction or the actual mining side, but when the ore is recovered, how can you sustainably process that to recover the cobalt that you need for energy storage applications? So these projects are just getting going, but they represent another $4 million investment kind of addressing these issues, which we recognize as a very small investment, kind of giving the scope of the challenge, but hopefully this will catalyze other activities. And then I just wanted to highlight some of the other work. So not only does our office fund the research and development through CMI, the team also does a lot of analysis on critical material supply chain. And so this is from our analysis group in the Critical Materials Institute, looking at the Chinese cobalt supply and how could a potential export restriction affect U.S. vehicle production. So, and being clear, we are not projecting a cobalt export restriction. That is not the commentary here, but it's just a kind of a warning system of if something like that happened, what would be the potential downstream impacts, especially as we're thinking about the costs for things like electric vehicle production. So kind of really what this shows is that there's a potentially quite a large impact, and it could greatly hamper cobalt or lithium-ion battery or EV production in the U.S. And really one of the key mitigation strategies that this study recommended was technological substitution. So things like flow batteries for grid scale storage, or how do we reduce cobalt in batteries, battery applications, as well as working with our allies to ensure we have other resilient supply chains to mitigate against any such disruption. So then just highlight some of the other efforts we're looking at is broadly kind of across the area of critical materials is the education workforce. So it's a significant challenge, especially in the United States, of not only new students coming out with the background they need to work in this area, as well as thinking about how do we train workers, especially in disadvantaged communities or communities that are transitioning off of fossil fuel technologies. How do we re-engage those workers in the manufacturing sector? And so CMI has a number of efforts in this. How do we, the Leadership Academy is training kind of a mid-career leaders or early leaders within the community to take on new research leadership roles within the national laboratory universities. We have things like a winter meeting where graduate and undergraduate students get to come and present on their research. It's one of my favorite meetings, is actually hearing the undergraduates talk about their work and then seeing them grow through their time in CMI until they're actually graduate students and now experts in the area. things like the externships, so actually getting scientists moving around within the labs and universities and industries to share knowledge. If you're ever in Golden, Colorado, I'd highly recommend that you visit the Colorado School of Mines and the Geology Museum. They have a great exhibit there and have a lot of touch points with K through 12 students that come in to visit and see various minerals and metals, as well as some of the work CMI is doing. And then CMI has educational toolkits. So these are this little kind of suitcase type at the bottom here. And these are available for teachers and organizations of all grades, K through 12 to universities, to explore various critical materials and some of the key applications. So I just wanted to highlight a couple of the kind of successes here, and kind of we have some things around better separation and processing of critical materials or rare earths specifically. Things like membrane solvent extraction. It can even be used not only for raw materials, but as well as recycling things like neodymium iron boron magnets. And this is particularly relevant for cobalt, as if we can, again, have better supply chains for neodymium for magnet, that frees up more cobalt that isn't going to samarium cobalt. And we're also working to actually recycle cobalt from magnet waste. So Electron Energy Corporation and Pioneer is looking at the electrochemical recovery through one of our Small Business Innovation Research Awards. And we talked a bit about the cobalt recovery from various sources, and just give you an idea of where some of the other areas we're looking at. We work with Rio Tinto, and they just announced a new battery grade lithium facility where they're recovering lithium from mining waste at their boron mine site in California. So they're at a demonstration plant capacity now, and looking to scale this up to actually produce enough lithium grade lithium for about 70,000 electric vehicles a year. And again, this was working through some of the research and development issues with CMI. And I believe this is my last slide, and just wanted to highlight kind of, again, we've done a lot of research and development over the last 8 years or so. And really with the new administration, we're looking about how to extend that technology development to the demonstration and eventually deployment side. So I just wanted to highlight 4 projects. Again, apologize, these aren't directly cobalt related, but hopefully show where the department's thinking about in terms of critical materials. So rather than just technology development, these are all pilot or demonstration scales. So how can we work with, we're working with General Atomics and Rare Element Resources in Wyoming to demonstrate a new rare earth separation capacity and technology. So at the end of the project, they'll actually produce from their ore, a deposit in Wyoming, 30 tons of neodymium and praseodymium for magnets. For battery applications, we're looking at how can you recover lithium from geothermal brines and then actually process that material into battery grade lithium hydroxide. So that's with Berkshire Hathaway Energy Resources and some other partners in the Salton Sea in California. And then we're also looking at graphite for battery applications. A lot of graphite production is on a batch basis. And if you can adjust that to a continuous process, a lot of energy efficiency gains as well as material gains, and looking to produce about 200 kilograms per hour of high purity synthetic graphite. And then exploring other resources. So in Nevada, there's some lithium claystone resources. And how can you extract the lithium and again produce battery grade lithium hydroxide? So with that, really appreciate the opportunity here. And I'll just kind of emphasize as talked a lot about rare earths and lithium, and probably less than cobalt than you might like at this meeting. But really want to highlight that is an important material for the Department of Energy, and we're expanding our efforts there. And we'll look forward to engaging with stakeholders, not only in the US, but globally, to get input as we're expanding these efforts. With that, I really appreciate the opportunity to participate in the conference. So thanks.
Mike, thank you for absolutely fascinating presentation. I mean, I think certainly from your presentation, Professor Persson, we see the breadth of the research that's going on in the battery space and in the broader critical raw materials space, which I think certainly talks to this being a key issue in the US, but also I think in other geographies as well. So again, thank you for taking the time and for talking to us today. Really interesting work, which I think we'll certainly be following up to understand more how we can become involved with you and your colleagues. So with that, I think it brings us to the end of our conference. I think when we started yesterday morning, we expressed our hope that we would touch on some, if not all, of the issues that were relevant and impacting the cobalt market and the cobalt industry. I think we have done that. I think we started the day one having conversations around sort of what has happened in the market over the last 12 months, thinking about what's going to happen this year into the market, but also looking more medium term, what will drive demand for cobalt. We then spoke a little bit about the supply of cobalt, thinking about where we will get cobalt from to meet the demand, as we see significant growth in demand really driven by electric vehicle batteries. And you know, I think we had some conversations around deep sea mining, land-based mining, and so on. So, and I think the robust nature of the cobalt supply chain as we look forward. We then also obviously spoke yesterday afternoon at length around responsible sourcing. Spoke with representatives from the DRC, with civil society, but also industry, how we can really work together to bring forward that ASM supply into the mainstream supply, so that we can make sure that those communities in the DRC are able really to benefit from their natural resources. And I think, you know, we touched on a lot of ground then. And then we finalized yesterday looking at the video that Mark Muller produced, looking at how those communities really rely on the raw materials sector in the metal sector to help support them, and how almost we have a responsibility to make sure that we're working to help those communities. And then today we've really focused in on the key application for cobalt. This morning we talked about the European battery regulation, which as I think we discovered is an incredibly ambitious piece of legislation. Is a piece of legislation that does have global implications and impacts. And we heard, you know, some Chinese perspectives on what that might mean for the value chain in China. And then we followed on with to talk about the impact and the role of chemicals management on our ability to use cobalt to develop those battery chains, and really the need to make sure that we're managing those risks and following the chemicals management legislation with recognizing that we need to also think about that broader policy agenda. And then obviously we were thankful for our colleagues from Benchmark for hosting their discussions before we came back this afternoon to really, I think, hear about some of the research, the cutting edge research that's going on with raw materials, with cobalt, with batteries, which I think certainly gives us a lot of areas for thought, and I think a lot of opportunities to engage collectively as we move forward. So I hope everyone has found the last 2 days to be both informative, stimulating, answered questions you might have had, created new questions in your minds. We certainly at the Cobalt Institute with our members certainly look forward to that continued engagement and those continued discussions. It remains for me to thank our speakers and to thank the audience, but also particularly to thank my colleagues at the Institute, without whose hard work and efforts over the last weeks and months, we wouldn't have been able to have the conversations we've had over the last 2 days, and allowing us to bridge hopefully the 1 year gap before we're able to have these meetings physically again in 2022. So, but again, thank everybody. wish everyone a wonderful rest of the day, a rest of the week, and we look forward to seeing you in May 2022 when we will host the Cobalt Conference in Vancouver. So thank you.